Da 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 da. Right, now we play the waiting game. Yeah. Let's just wait for people to arrive. Are people going to arrive? Is my thing actually... It says I'm offline, but that's demonstrably false. Let's just try refreshing this whole thing. Still says I'm offline. That's interesting. Well, we shall wait and see if anyone actually turns up. Let's refresh that page. Does that make any difference? Oh, it says I'm live now. It says there's one person watching. Oh, and there he is. The is that communist bear? It's your avatar. I seem to recall using that picture in a mock we had once. Remember that? Okay, so current time is 5:41. Feel free to a Celtic. Good, yes, that's amazing. Right, feel free to inform the others of the shenanigans that are now unfolding. I see a few people are tuning in. We'll wait a little while to gather. I have the spec up here on the thing. Obviously, paper 1 done. Don't have to worry. Paper 2 is what we're going to be looking at now. So yeah, I'll wait a little while for people to arrive. Plan is to go over some stuff involving algorithms. That includes flowchart, pseudocode, the 3 sorting algorithms and the 2 searching algorithms. Also some stuff involving digital audio, how binary is used to store digital audio. That falls under the category of data representation there. We could do a quick bit on translators and the facilities of languages. And yeah, we'll see. We shall see how it goes. Okay, I've told a few. He says. Okay, that's très intéressant. Hello, Charlie. So, if I aim to give people enough time to get in here before we launch. It is currently 5:43. So maybe if we wait until it's a great live stream yesterday. Glad you enjoyed. Did have some RuneScape music, me singing the RuneScape music. So there was a thing. Yeah. So if we wait until about 1:45 or maybe 10:45, we can get cracking with this whole thing. Hope your English exam went all right today. Hope you Englished as well as you possibly can. If not, as I always say, it's done now. So whether it was good, whether it was bad, put it out of your mind and focus on what lies ahead. This is cheap Tesco orange juice, and you know what? It's great. I'm tempted to go and make myself a cup of tea while I wait for people to sort of drip in. English is bad. You mean English as a language, or your English is bad, or what's the crack there? Because I mean, I quite like English. It's the language I use to communicate, and that I quite like that. And I like reading books as well. I read tons of books, and they're all English. So I mean that's kind of cool. Hi Gabe. Mainly the subject. Yeah, I mean, in a way, it's sort of like it can drive the fun out of things. But you know, it's a thing. I would always recommend everyone reads more. No matter how much you are reading, you can be reading more. Books are a wonderful thing. Maths is greater than English, yeah, but surely computer science is greater than everything, right? That's your priority right now, because that is tomorrow. Have you got maths tomorrow? Is it maths tomorrow? What is it tomorrow? I know obviously computer science, but something else as well, presumably. Ah, chemistry. Chemistry is just applied physics anyway. Right, so if we give it 4 more minutes. Oh, good old Flame Tests and Precipitates sounds like a band, an indie rock band, you know. So there you go. No, I'm not playing RuneScape. I have no intention to play RuneScape now or ever. It's just I heard there was a metal version of the RuneScape music that I saw on the thing. Internet. Yep, that's what I saw. Why? Because after working on 2 MMOs for a long time, I never ever want to touch an MMO ever again. No interest in Minecraft. I know. How long is this going to take? Well, I mean, it's going to take as long as it's going to take. You know, I mean, feel free to dip in and out. The stream will remain up once it's been done. My plan was to spend maybe an hour and a half, but in the past it's gone on 3 hours. But you know, there's nothing stopping you from going off and doing your other thing. Conquer the world is Germany. Okay, maybe. Right, shall we make a start? I mean, we've got a reasonable amount of people here, so yeah, start now. A monarchist German, yeah. I mean, you know my thoughts on the monarchy, right? That's, you know. Anyway, let us begin. So at the moment, le moment. Oops, I've just done. I done messed up. What have I done? Yep, that's the one. That is the one. Okay, so let's have a look. We've got all of this stuff. I figure if we start off with, I was going to start off with digital audio, and then maybe do the algorithms, or is there a specific order that you want to do this? I mean, lined up here, I've got some stuff on flowcharts, I've got some stuff on pseudocode, I've got some stuff on digital audio, and then I've got the what's it called? Any preference on where to start? Algorithms is horrible. Do that. I'd rather go through it first. Okay, cool. So, okay, let's. If we start at the start, let's begin at the beginning. Pseudocode, algorithms, then sound. Okay, right. So, I'm guessing that you're all like you kind of get how flowcharts work, right? Flowing chart, yes. Okay, so let's have a look at the old flowchart. What is the hard stuff in the paper? Well, I mean, the hard stuff is it's testing your ability to apply the knowledge that you have. So it's not a case of necessarily just remembering facts and regurgitating those facts. It's more about remembering those facts and then actually using them to solve problems. So in a way, the hard stuff is the problem solving. But you know, what I will say is the non-exam component, that coursework stuff that you did, think about all of the stuff that you did in that, because a lot of that feeds into the exam. Something like 40% or more of the questions are going to be centered around the same sorts of tasks that you were performing there, in the sense of planning, implementation in pseudocode or a high-level language, also things like testing, and also the features of the IDE that you were using, being able to read syntax errors and debug your code. That's the sort of stuff that is gonna pop up. It's like, yeah, you say ooh planning, but you know, if you ooh planning and ooh testing, but they're both vital parts of the system's life cycle. If you don't plan properly, then you end up spending way longer than you have to on the implementation. And if you don't test, then you're probably going to end up with a broken pile of rubbish. For some reason, students hate planning, and I've never really understood this, because if you get the plan right, the implementation is totally easy. But if you don't bother planning, then you end up stuck with how to implement. So. There we go. So just a quick reminder of your flowchart symbols. These are the only ones that you actually need to know. So you've got your start and stop is this rectangle with rounded edges. You've got process, which is just a task. So for instance, x plus 3 is a process. That's your rectangles. Input and output both share the parallelogram. Now, things to bear in mind, right? Input and output. Anytime you are reading from a sensor, for instance, like if you are reading the temperature or something like that, or you are reading data from a card, that is input. Okay, anything that is outside of the system and goes into the system, that is input. Okay, which means if you've got like a card reader and you want to read the card, don't do what a lot of people do, which is put the process symbol there. You want to make sure its input is any time you are reading anything. Output includes so input includes, like, reading from sensors, but also asking the user for input. So asking them a question. You have to input stuff from the user before making decisions on that, right? So we'll have a look at an example in a sec. And then output is anything which is coming out of the system. So that might be something printed on the screen for the user to read. It also might be activating an actuator or a motor or something like that, or even something like turning on the fan. That is an output. That's not a process. Okay. You can't believe what exists. How do you add subroutines? It's highly unlikely that you would need to add a subroutine, but let's see if I've got the old symbol. This is a, if I draw that, this is the subroutine symbol. Okay, so subroutine, spelled that wrong. That's subroutine. That's a subroutine. Okay, it looks like a process, but it's got these 2 extra bars. So the way that it works is you would put that symbol in, and then you would have a separate flowchart with its own start and stop and all of that lot. And basically, when your main flowchart hits the subroutine, it basically goes to that other flowchart. So in the same way that you define a function in Python, for instance, and then that function gets run when you call the function, it's the same deal here. So yeah, it's a separate flowchart, and then you use this symbol here. But the paper says that these are the symbols you need to know. So there you go. All right. Would establishing a variable like sum equals 0 before any input be a process? Yes, it would be a process, because that's an internal thing. You're not taking any information from outside the system. You are inside the system and you're saying, here is a variable called sum, and I'm assigning this value 0. Boom. That's a process. If using Google Slides, can we have the link so we can go through it ourselves along with you? It's available on the Google Classroom for my students, but I guess I want to call Data Protection Act on limiting. I mean, I might be able to make it available. If you leave that with me. I'll maybe sort that out. So here we go. We've got a example flowchart here, right? Got an example flowchart. I want you to just go through this flowchart, but instead of just thinking of a number, let's assume the number is 3. Okay, so start off with the number 3. Go through the flowchart. And yeah, but Freedom of Information Act. You have to send an official Freedom of Information Act request if you want me to send that out. And also, Freedom of Information Act does not pertain to, like, you know, educational presentations. That's not really the sort of thing that you're after. Anyway, Freedom of Information Act is paper 1, and that's done, so you don't have to worry about that, right? So start off with the number 3. Okay, I want you to write down the output as you go through this flowchart until you reach stop. Okay, so follow the flowchart. Remember, you've got to follow the arrows. You've got to do exactly what it says depending on where the arrows are. Okay, and see if you can write down the output when we start with the number 3. Okay, I'll give you a couple of minutes to do that, and then I'll come back and I'll do the I'll show you the what the output would be. Okay, so when I say write it down here, I mean that's like, you know, that's like output it. Hexadecimal I covered in Tuesday night stream. Was it Tuesday night? I streamed on Tuesday night and I covered hexadecimal in that. It should still be up if you want to go over that. But maybe if we've got a little bit of time later on, we'll just like brush up on that. If you use 4, then it's an infinite loop. Are you sure about that? Yeah. Yeah, right. Yeah, 4 is even, exactly. If the number is even, you divide by 2, and then 4 divided by 2 is 2. Is the number 1? No, it's not, so we go back round here. 2 is still even. You divide that by 2, and then the number is 1, so you stop. Okay, so let's just go through this. Okay, so if we start off with the number 3, we're starting off with the number 3, right? We start here. We've thought of a number between 1 and 5. Now, if we were asking the user for a number between 1 and 5, we would have this as a parallelogram, the input thing. So we're going to write it down. I said that the number would start off with 3, so our first output is 3, like that. Okay. So is the number even? No, it's not. Now look at what I've done here on my flowchart. Right, I've got arrows clearly coming out of my decision boxes, and they are clearly labelled. A lot of people will draw arrows, or they'll just draw lines without arrowheads, and they won't label the things. Okay. Okay. So I tell you what. What about 4.5? There you go. Is that better, Charlie? Think of an integer between 1 and 5. There we go. Yes, I will be in from 7:30 tomorrow. I'm not sure if I've got enough flour to bake any cakes. I might be able to do some brownies. I'll try and bake some brownies a little bit later on, and then I'll bring them in as well. Everyone's a critic. There we go. Yes, so don't worry. I'll bring plenty of food. You'll be well fed before the exam. All right. Okay. So the first time I've written down 3. Is the number even? No, it's not. Okay. So we go down here, multiply by 3 and add 1. Now 3 times 3 plus 1 is 10, right? But I'm not going to write that down because it hasn't told me to write it down. Remember, we only write the stuff down if it says write it down, if it's an output. Okay, so now we're coming down here. Our number is still 10. Is the number 1? No, it's not, so I go all the way back down here. And this is the point where I write it down. So now I write down 10. Okay, so now here I am, and we're going down here. Is the number even? Well, the number is 10, so we are going to divide that number by 2 here, and we get 5. Again, not writing it down just yet. Is the number 1? No, it's not, so I'm going all the way back round here, and now I write it down. I write down 5 there. Okay, so back through we go. So we got 5. Is the number even? No, it's not, so we multiply by 3 and add 1, and I get 16. 3 times 5 is 15, plus 1 is 16. Is the number 1? No, it's not, so I loop all the way back round, and I go 16 in here. You see how this is working, right? Is the number even? It is even this time. Will the computer room be open for the exam? Yeah, I'll be in there from like 7ish. So just drop in. I do have my tutor group in there though, so just be aware of that. Is the number even? Yeah, it is. So we're going to divide by 2. That is 8. 8 is not 1, so we're going back down here. We then write it down. Okay. I mean, this is fairly straightforward now. 8 is still even, so we're going to divide by 2 again. That's not 1, so we loop all the way back round here. We write down 4, and then we go through it again. And we're back to where we were a minute ago when I said, oh yeah, the room will be open at lunchtime, yeah, and I'll give priority to year 11, so I'll kick anyone else out and tell them sling their hook. Okay, so round and round we go, all the way down here, and then we output a 2 there, and then 2 is still not 1, so we go back round. Is the number even? Yeah, it is, so we're going to divide by 2 again. Now, is the number 1? Yes, it is, so we stop. You will notice we have not output that last 1. Okay, so those of you that are following along with this, I chose 3 because that's the number that like takes you on the wildest merry goose chase. Okay, but notice that because we are outputting the number at this point, right, we don't actually write it down when the number is 1 because we exit straight from here. Okay, I mean, if we wanted to write down that number, we'd have to have a separate output thing here. Okay. Cool. So I mean, the things to remember with flowcharts, as long as it is 291,643,136 between 1 and 5. There we go. It fails the basic range check. Okay, I put validation in there from the start. Okay, so things to remember about flowcharts. All you need to remember are these 4 symbols. You also need to remember to draw arrows. Don't just draw lines. Put arrowheads on there as well. Yes, they are HyperX clouds. Also, make sure that you clearly label the paths out of your decision boxes. And remember, every single box has only a single arrow coming out of it, except for the decisions. Decision boxes have at least 2 arrows coming out of them. They might have more, right? But they have to have at least 2. Every other box only has 1 way out, except for the stop, which doesn't have any. Okay? Almost all boxes will have multiple routes in, okay, and a single route out. That's what you need to remember. Yes, there is a thing tomorrow morning. Get the impression that it's 16 people. We seem fairly popular. Have I got 16 students in my class? Interesting. Okay, anyway. We're not going to do this task because you don't have the worksheet. All right, and we're not going to go through the rigmarole of writing an algorithm. I mean, literally every computer science teacher in the country probably does this exercise. It's pretty dull, isn't it? So we're not going to do that. You can do that in your own time if you want, and I will I'll give you some ideas on the what's it called on how what the quality of your flowchart is. But I'm guessing, and call me crazy, right? But I'm guessing that most of you are probably pretty good with flowcharts already. Does that sound fair? Mr. Hawley. Oh, okay. Mr. Hawley did make a sandwich. Probably didn't have cups of tea back in his day, or something. Right. Main issue is for and while loops and algorithms. That confused me. Right. Okay. So what I'm going to do now, I mean, if I don't have any complaints from you guys, if I move on to looking at pseudocode and what that actually means and how we can start to construct pseudocode from flowcharts, does that sound like a good shout? If we move on to that now. In the subject of 2D arrays and audio stuff, we are going to be having a look at audio stuff shortly. Okay, so audio stuff will be in there. Okay, so yeah, pseudocode. Cool. Okay, right. Let me just pull up my second presentation. Here we go. Pseudocode. Look at this hilarious joke. Algorithm. There's a politician no one knows anymore. Okay, anyway. So pseudocode. Pseudocode means not actual code. Conditional and count-controlled loop. To answer your question, Charlie. So pseudocode means not actual code. It resembles code, right? The thing to remember about pseudocode, which everyone seems to like get flustered about, there is no set syntax. Okay? If you are not sure what to write for pseudocode, write it in English. Okay? Write it in English in a structured way that has no ambiguity whatsoever. Okay? It's not going to be perfect, but that's better than not writing anything. Okay? So you've got to remember that pseudocode is it's a way of presenting code in a non-language specific format. So the idea is you write you'll plan your programs out in pseudocode, and then programmers of whatever language, whether that's Python, Java, C++, C#, any of those programming languages, they can take that pseudocode and they will be able to implement that code. Okay, so it's important to make sure that it's doesn't contain sort of Python specific stuff or whatever language you've been learning. It's got to be fairly generic. Okay, but remember, there is no set syntax. You're not going to get a traceback error if you've only put one equal sign instead of two equal signs. That's not how pseudocode works. As long as the meaning is clear, you can get away with quite a lot. Okay, and I think that's the point where a lot of people sort of like, pseudocode, I hate it. They hear the word and they panic. So like I said, let's write like I'm doing Python. But if you make it too much like Python, then you run the risk of just them saying that ain't pseudocode, that's just Python. There's a fine line. There is a pseudocode guide at the back of the spec. So if I just scroll down to the back of the spec here. So this is the sort of pseudocode guide, and most of it is fairly Python-y. Your teacher was telling me that if it says pseudocode, then just write in Python. Well, your teacher's kind of not really that. Yeah, I mean the code needs to be understandable, but if it's too much like Python, that's not pseudocode. Remember, Python needs to be language non-specific. But like I said, a lot of this stuff is very similar to Python. So for instance, assigning variables, exactly the same. Like x equals 3, name equals Bob. Strings have quote marks around them, right? What's that file called on the classroom? It's in the algorithms lesson presentations section. It's called, this is algorithms 2 pseudocode. And typecasting as well, converting from one data type to another in the guide at the back. It's pretty much exactly the same as it would be in Python. Okay. So next up, output. You can use output. Okay, but they say you can use print, so that looks exactly the same as in Python. You see how this is going? In fact, even their input, with the guide that they say for input, that's exactly the same as Python. WTF is casting. Casting is where you convert from one data type to another. So, for instance, if I have a variable called age, right? Remember, when you input from something from Python using the input command, it will store that data as a string, right? So even if you type in the number 3 or the number 56 or whatever, that will still be stored as text data. You need to convert it to an integer, and casting means converting from one data type to another. So converting from strings to integers, converting from integers to float, converting from booleans to different to various other things as well. What's the difference between return and input print? There's a whole load of difference between return and input. I will try and answer your questions as much as I can, but I'm just going to sort of like go through this stuff, and then I'll sort of like go back and answer a bunch of questions, right? So just sort of like follow along. So the two types of loop that we're being asked about. This is where the pseudocode recommendations in the spec differ from Python. Okay, so Python, you would say something like for I in range 7. Okay, that's a very Python-y thing. For pseudocode, I would recommend not writing for I in range 7. Okay, I would put for I equals 0 to 7. Right, that's how it works. Right, and at the end of your for loops in pseudocode, you should always mark the end of your for loops with a next. Okay, so you can see here for I equals 0 to 7, print hello next I. The way that this loop works is we're saying create this temporary variable called I and initialize it so that it equals 0. Now print hello. And now go to the next value of I. So we go back up to the top of the loop, we assign the next value. Okay, the next value after 0 is 1, and we go through the loop again, print hello. So we end up printing this 7 times. Okay, or 8 times in fact, because whereas Python range doesn't include the upper bound, OCR script, if you want to call it that, uses it's inclusive, both of them. Okay, so input. Let's just go through this return input thing, because there's a lot of chatter going on there. So when you input something, you are asking the user, or you are reading some information which it's information which exists outside the system. Okay, information in the real world, for instance, and I ask for input. I take that information from the real world and I put it into my computer, yeah, and then it becomes part of the system. Output, or print, that's when the stuff comes from the system and it gets output and it comes back into the real world. Did you like my amazing hand movements there? That was pretty great, right? And return is not the same. Return will not output anything, right? Return, all that does is it sends that value back from a subroutine, right? We'll have a look at that in some more depth in a sec, all right? So the two types of loop that you need to know about: for loops, count controlled loops that I've just gone over. The other one is the conditional loop, which is your while loop. Now you'll notice at the end of this while block there is an end while. You don't have to put that in Python. Yeah, no, it's not waves. It's dreads. So there you go. It's not a beanie either. It's sort of like open at the back. Anyway, there you go. Yeah. The while loop will run until a condition is met, or until a condition is no longer met. But you've got to put these things there. Now, something which might occur in the exam in terms of pseudocode, but doesn't actually exist at all in Python, is the do until loop. Okay, and this is very important. It basically functions in exactly the same way as a while loop, but it will always execute at least once. Okay, so for example, I'll just use this example here. If I do no, it'd help if I was actually typing. Do d dot, I can't type. Do new line answer equals. I'm not going to be able to space this out. Input. What is the password? I might reduce the size of this text because it's clearly not fitting in. Until answer equals complete. complete. Something like that. I'll just reduce this size so it sort of like fits on. You still read that? Is that text still readable? I don't know if that text is still readable. Whatever. Okay. Yeah. Okay. So the idea is, it looks like it's chopped off at the side there. Okay, maybe not. I don't know. Whatever. The thing is, right, you won't be able to do that with a while loop because you have to go through that. Yeah, that's what I thought. It's a little bit cropped, isn't it? It doesn't seem to be updating on my thing. Give me a sec. Nope, that ain't having it. Okay, I might just have to abandon that. Oh no, here we go. It's coming back. No, that's the chat. That's really not what we want. Cool. Yeah. So to answer your question, I don't know how to fix that. Well, I do know how to fix it, but it's not a quick fix. I'll sort that out in a sec. No, we want Genie. There we go. Crop left. There we go. That's better. See, I am a computer scientist. Now, with a while loop, the equivalent while loop for this would be something like complete equals empty string while. Oh no, wait. Answer equals empty string, and then while answer does not equal complete. Answer equals input. What is the answer? No, sorry. What is the password? Okay, so you could, and then we'd have a end while. Okay, so you can see how it's fundamentally different here. There's no guarantee that a while loop will even run. Are you using YouTube Lite? I'm using whatever the default settings was because, like, I got in from work, right? I made myself some dinner and then I hopped on this. Okay, this is all for you guys. I hope you appreciate that. So the whole point is, like, a do until loop will run everything in the loop at least once and possibly more times, whereas a while loop, there's no guarantee that it will run the first time even. For instance, if I had that answer equals complete while answer does not equal complete, it will skip over that, right? But at the same time, if I had this, if I had that at the start of my do until loop, even though answer is already complete, the inside of that loop would still run once. Okay, does that make sense? Hopefully that makes sense. Right, Blessed, I apologise for using a light theme on YouTube, right? I mean, it's not my preferred choice. You know, I use dark themes for everything. Stop getting at me, right? Or I'll report you for bullying, cyberbullying, all right? Okay. So anyway, right? Operators that you need to know about: equals, not equals, less than or equal to, greater than or equal to. They are all the same as in Python. There are some differences with the arithmetic operators. Plus, minus, multiply and divide, they are all the same, right? But mod, instead of the percent sign, it's just the word mod. Okay, so mod gives you the remainder of of a sum. So 12 mod 5 gives you 2. Because 12 divided by 5 is 2 and 2 remaining. So mod gives you the remainder. Okay. Div is integer division or quotient. That's equivalent to the 2 slashes next to each other in Python. So for instance, 17 div 5 gives 3. It's just like doing division, but instead of storing it as a float, it stores it as an integer and just chops off anything after the decimal point. Okay. Now, annoyingly, they use the same symbol or a similar symbol for exponentiation as they do for the AND logical AND. Okay. So this was on the last paper. Yes, algorithms and pseudocode can appear on either paper. In fact, you're more likely to encounter them on paper 2 than on paper 1. So it's worth knowing. And usually as well, whereas the one on paper 1 that with the what's it called, encryption thing, that was sort of fill in the blank sort of deal. Whereas with the paper 2, you're more likely to actually have to write it yourself, if that makes sense. What is the Python equivalent of a switch case? Yeah, as Mark says, there isn't really one. I mean, it's a bunch of ifs and elifs. So, for example, there's this switch down here. We've got switch entry. In Python, to do this equivalent, you might do something like, I don't know, if entry equals A, then print you selected A, for instance, and then you'd have an elif entry equals B, print you selected B, elif entry, oh no, sorry, default, else print unrecognized selection. So yeah, with Python, ifs and elifs, they are equivalent to the switch block here. Okay, so would there be any question where you must know how to write a switch case? Potentially. It's more likely that you will be given part of, an incomplete switch case. There might be a question where they say something like, here's a switch block, convert it to like an if statement. But the way to remember it is this. Okay, if I just copy this stuff here, or maybe can I zoom in on that? Ugh. Is that right? So we've got us. So this is the code here, right? The switch, where it says switch, that's you setting up the block. That's like saying if or def or for or while. Okay, that's you saying this data structure is a switch block. Okay, and then that is the variable that you are checking. Okay, so switch, we're saying run this switch block and check the value of this variable entry. Okay, case A means in the case that the value of entry is A, then do this stuff, print you selected A. However, if that's not the case, in the case that the value of entry is B, you print this block. Okay, now default is like your else in an elif statement. Okay, else, so default, if none of the above cases have happened, then this is what you go to. Okay, so just compare the switch block here with my if elif statement here. Okay, if entry equals A, print you selected A. That is the same as saying switch entry, case A, print you selected A. Okay. Yeah, case is a lot like an if. It's like it's a lot like an if elif block. Okay, you just got to remember the syntax for it. Okay, and I know I said that pseudocode doesn't have syntax, but this is a set sort of data structure. Okay, so you're saying switch. This is the start of it. Okay, this is the start of the conditional structure, and here entry. That's the name of the variable that you're checking. Okay, so if you had a variable called age, for instance, and you were checking to see if like the age was less than 15 or greater than 15 or I don't know, less than 3,000 or something like that, you would use switch age. Does that make sense? As an example, just to carry on that example, if I did switch age, okay, I would have something like case less than 15, okay, print youngster. Okay, and then I might have case less than I don't know, 30 maybe, print mid-band or something, and then case instead of case, well, just have a default after that. Default print oldster. Okay, and then end switch. Do you see how that's structured, right? Yes, switch is very similar to if. It's not the same, but for all intents and purposes, for what you're going to be asked about, yeah, it will be the same, right? So you can see here, switch age. We are checking the value of age. In the case that age is less than 15, we're going to print youngster. If that's not the case, we're then going to check to see if case is less than 30, and we're going to print midband. If that's not the case, then we default to print an oldster. Okay. Yeah, obviously I'm biased, but computer science people with computer science degrees are generally the best people. You know, just case in point here. You can see on my wall there. Oh God, look, that's a picture of Alan Turing above my computer. My friend drew that for me. Pretty amazing, right? Anyway, did he have a computer? Well, he kind of invented the whole deal. Oh God, I've messed up my webcam. Sorry. There we go. Right. So, if you're not sure what the deal is with switches, I wouldn't get too wrapped up in them, right? Because as long as you understand if and else if and else, you know, you should be all right. Okay? Right. Now then, should we get stuck into something new? Someone mentioned two-dimensional arrays and stuff. We can go through that in a sec. I'm just going to pop back to my pseudocode thing here, right? This is the flowchart from earlier. Okay, this is the flowchart. I'm not good enough, right? So just to let you know, the A-level computer science, there's a good portion of it which is basically just GCSE revisited with a few extras. Just throwing that out there, okay? And you can. I've had students come into A-level computer science that have not done GCSE computer science. So just throwing it out there, just because like you're not. You're not necessarily great now because you might have messed up the last couple of years. That doesn't necessarily mean that you're you're destined to fail. I'm just throwing that out there. So anyway, we've got this flowchart here. Yeah, this is the one from before. Okay, I am going to show you what that might look like as pseudocode. So to answer that question that Sam's just asked there, if it says write an algorithm, can I write either pseudocode or flowchart? Yes, you can, unless it specifically says to write one or the other. Okay, if it says write draw a flowchart, then you obviously have to draw a flowchart. If it says write pseudocode, then you obviously have to write pseudocode. If it says design an algorithm, you've got the choice, right? So there's that. Will you be doing A-level computer science in 2 years? I'll be doing. I've got my current crop of A-level students. I'll be doing some stuff for them. If that's directed at me, I don't know. When asked to write out an algorithm and it isn't stated how, blah, blah, blah. Yeah, I've just answered that question, so rock and roll. So here is the flowchart from before. Remember, we thought of a number between 1 and 5, write it down. If the number is even, we divide by 2. If the number is not even, we multiply by 3 and add 1. And then we keep on doing that until the number is 1, and then we exit. An example of how the pseudocode might look. Now, bear in mind, this pseudocode is fairly old school, right? I mean, you could get away with a more Python-y version now, but still, it's it's pretty much the same. I would probably change this. So instead of saying think of a number between 1 and 5, I'd probably do something like num equals input. Give me a number between 1 and you know what? I'm gonna just say number between 1 and 5, just so that it fits on one line. Okay, so there we've got num equals input number between 1 and 5. Now in Python you'd obviously have to cast that to an integer. Pseudocode don't have to do that. We're assuming that we're inputting the stuff in whatever format we need. Obviously now that I've called that num, I'm gonna have to make sure that I call this num, and instead of output num, probably change that to print num. Okay, we are going to repeat print num if num is even. One way of checking to see if a number is even, here's some top tips. If a number is even, then num mod 2 will equal 0. Okay, if num mod 2 equals 0, then number equal, well, we can change that to num. Num equals num divided by 2. Else num equals num times 3 plus 1. Okay, and then I've got an end if at the end. Okay, so we can see all of that if is joined together. Okay, I could do a select a switch block for that, but I'm not going to bother doing that. Okay, and then I've got this until number equals 1. So this is another example of one of those do until loops. It's going to go in, it's going to go through that whole thing, so probably, I mean, that might be a bad thing, because we might want to check to see if the number's 1 at the start, right? So but I'm just following this exact pattern here. Okay, now as I said before, right, when you see pseudocode, I don't want you to panic. What I want you to do is just think about it logically. All right, you can get away with writing a bit of Python, but you've got to make sure it's not entirely saying, yeah, real is the same as float. You've got to make sure that it's not entirely the same as Python, right? But if you're ever in any doubt, if you're really not sure how to calculate something, like for instance here, if you don't know how to check if something's even using modulus, if num is even, that's good enough in terms of pseudocode. You can get away with an awful lot of stuff. Okay. I've said this 1,000 times, but I'll say it again. There's no set syntax for pseudocode. There are many different ways that you could write it. Okay. I tell you what, I've got a revision paper here. Let's just have a quick look and see if I can find some pseudocode looking questions here. So what about this one here? The area of a circle is calculated using the formula pi r squared, where pi is equal to 3.142 and r is the radius. Finn has written a program to allow a user to enter the radius of a circle as a whole number between 1 and 30 and output the area of the circle. Okay, so you can see what's going on here, right? Have you only just twigged that, Blessed? Wait, who's your sister? Do I teach her? Right, anyway, so we've got this pseudocode here, right? We're starting off by defining radius equals 0, and we've started off by defining area equals 0.0. You'll notice this is something else that you can do in pseudocode that you don't do in Python. You specify the data types when you initialize the variables. Okay, so there you go. Right, cool. So then we're inputting the radius. Why? Someone answer in the chat here. Why have we defined radius before we've asked the user to input radius? What's the purpose of that? Yes, it's initializing the variable, but what purpose does that serve? Why is it good practice to initialize the variables? Who is they? You mean the user? The user might put something in wrong, yeah? It might be that at this, like, I'm just going to hold fire here because you said you have to convert to an int. Remember, this is pseudocode. This is not Python. When you input something in pseudocode, you can assume that it's going to be input in the correct format. Okay, so yeah, I mean, the reason we initialize variables, and this goes into the section about like designing robust programs, if you try and use a variable before it's been declared, you can run into problems. So usually at the very start of the program, any variables that we're doing, we have to assign. Now in some programming languages, it's absolutely necessary to do that because the memory space needs to be reserved. Now remember, a variable is a place in memory. That's what a variable is. It's a place in memory that is assigned a name that stores some value that changes over time. Okay, so sometimes it's necessary to reserve those places in memory so that we can put stuff into it, and that's why we initialize the variables. Okay, now I'm not sure whether you'll get a question asking you to explain why we initialize variables in that much depth, but that does fall under the category of designing and implementing robust programs, which is a section on the spec, right? So we input the radius, and then we've got this check. If radius is less than 1 or radius is greater than 30, then print, sorry, that radius is invalid, else area equals 3.142 times radius raised to the power of 2. Okay, and then print the area and end if. So can someone suggest to me one way that Finn can make his code a little bit more readable? Indentation. Boom. Okay, yes, indentation is that's your one-stop shop to allowing you to easily see which code blocks belong to which structures. Okay. Yes, even pseudocode, indent it. It's not required, but it makes it so much easier to read. Comments is another thing as well. Okay, even in pseudocode, you can add comments. Okay, because if you are writing something in pseudocode, and you remember, the reason you design these things in pseudocode is because often the person that designs the algorithm is not necessarily the person that's going to be implementing that algorithm, and so you want to make sure that the people who are reading your pseudocode are able to actually implement that in the way that you envisage, and the way that you can do that is by adding comments to clear up any sort of obscure looking code. Okay, in terms of the comments, yeah, I mean, a hash or 2 forward slashes, sometimes a slash and a star, and then whatever your comment is, and then a star and a slash. That's, yeah, it doesn't really matter. Okay, hashes are generally recognized in pseudocode, so there's nothing stopping you doing that. It'll be pretty obvious what's a comment, as long as you put one of these symbols at the start of it. Okay. Let's just have another look and see if I can ask another question on this. Okay, so what is the purpose of that line 4? There's a word with V, okay, that line 4, 5 and 6, they are all related to this one thing. Can anyone tell me what that thing is? That word with V begins with V. I will point out that the people that mark the computer science papers are not necessarily computer scientists. Okay, just throwing that out there. Yes, validation. Validation is what I'm looking for. Validation, remember, validation is where you check to make sure that the data that has been input is what you're expecting to see. Okay, can anyone suggest to me any of the different types of validation that should be used? There are a number of different checks. Okay. I I'll give you a clue. The validation which is used on line 4 is a range check. Okay, a range check checks to make sure that your input is within certain range. Yes, format check is another one. What else is there? Character case might come into it. Okay, but you might want to just switch everything to uppercase, switch everything to lowercase before you compare, but that possibly might fit in there. What's Darth Vader's favourite check? There we go, the presence check. Okay, presence check to make sure that they've actually inputted something. If they just hit enter, you don't want to carry on. You want to make sure that they've actually entered something in there. And there's one beginning with D. No, you're not going to fail, Henry. You'll be fine. Okay, stick with me. You'll go far. Not yes, data type check. Okay, and this is something which is very important, especially when you're using Python and all input from the command line is a string. You know, you've got to make sure that you convert that to the correct format before you start processing it. Otherwise, you're going to have some. You haven't had a computer science teacher in 2 years. Help us from the... Right, I'll level with you guys. I can't teach you the whole course in a couple of hours, right? But there are a number of videos on this channel which might help you out, right? I mean, it's a little late to go through all of it, but I'll go through as much of it as I can, you know. Exam is 1:30 p.m. Yeah, it's afternoon, right? Okay. Wicked. Right. So, what was I going to do? What question would be a checks? I'm not sure what that means. They might ask you, like, to spot in pseudocode where the validation check has been made. Okay, that's one thing that they might ask you there. Just having a scroll through these, see if I can find anything else here that might be of interest. Right, okay, here's a question then. I'll tell you what, I'll just go back to that other one with the pi pseudocode in there, because there was an interesting question at the end. Finn uses an IDE, an integrated development environment, to write his programs. Identify 2 features of an IDE that Finn might use. Okay, so you know, just suggest to me two possible features of an IDE that Finn might use. While you do that, I'm just going to go and grab myself a drink out the fridge, and I'll be back in 2 secs, alright? Syntax checker, debugger, color coding, running the program. Running the program. That seems a little bit obvious, but there you are. Yeah, something that tells you where the error is. The translator. When you say syntax, Sam, what you really mean is syntax highlighting. So that color coding of the different syntax, so you can see where strings are and whatnot. I tell you what, I might be able to. Just bear with me 2 secs. I'll just open up PyCharm here and Peacehaven. That place sounds lit, man. So just as an example, let me just create a new thing in Bob. I want a window capture. Create a new one. What is the source? It is that. Boom. Okay. So here we are. Here's my pie charm. Let me just get it into a position so you can still see my lovely face. Here we go. So yeah, I mean, here we are. This is PyCharm, which you may or may not be familiar with. You'll sound cool if you call it P-Town. Yeah, big up the P-Town Massive or whatever. Here we go. We've got syntax highlight, and you can see here keywords are coloured in orange, and the name of the function here is in this yellow colour. There's also integers are coloured in blue. If I was to put a string in here. Like that, you can see the string is coloured in green. Now, the way that this helps us out, if you forget to put a closing quote on there, right? You'll notice what happens is the rest of the line is all green. Now, sometimes the whole, the next line as well will be green. Not with Python, but with things like JavaScript and stuff like that, it will be, and that will help you pinpoint where it is, that you've missed it out. The other thing as well, right? You'll notice if I put my cursor next to this bracket here, the opposite bracket is highlighted. If I put my cursor next to this parenthesis here, the opposite parenthesis is highlighted. Okay, all of this stuff. This is all stuff that you need to know. How the stuff helps you. The debug mode, if you put a breakpoint in your program, then when you run it in debug mode, what happens is it runs all the way up to the breakpoint and then it pauses, and you can see the current contents of variables in memory. Okay, what do you call it when the IDE tells you what line your syntax error is on? That is called error reporting. Okay, in Python it's known as a traceback, but generally speaking it's called error reporting. So for instance, if I was to do this and then run my program, you can see here we've got an error. It usually tells you the line number, it tells you the type of error, and sometimes it might have a guess as to where that error is. Okay, so I tell you what, I'm just going to go back to the spec quickly. Let's scroll up to the subject matter. Oh no, it's gone away. Where is it? There we go. Scrolling down. Right. Okay. So let's just focus in on the algorithm. Yeah. Thanks. I quite like my hair as well. It's pretty rad, right? Okay, I mean, I would obviously recommend focusing on your revision before you go onto your games, because if you revise well, you can get a job making games, which is what I used to do. Right, algorithms. So you need to know about computational thinking, which is abstraction, decomposition, and algorithmic thinking. Now, as I said to all of my students, you'll not be asked a question that says, what is abstraction? Okay, it's just you'll be expected to be able to use those skills to solve these problems, right? You need to know these searching algorithms and sorting algorithms, and you need to be able to interpret correct or complete algorithms, right? So, yeah, no, gamer does not equal slacker, but at the same time, you know, it's all about getting priorities right, okay? We got asked what the CPU stands for. Yeah, I mean central processing unit, right? I mean, well, the thing is, if you found paper 1 easy, that might be that paper 2 comes in like a ton of bricks or whatever. Okay, so just be aware. Right. So if you want now, we can go through these search algorithms, sorting algorithms even. Right, and we can start off with the bubble sort, the boobly sort. Okay, so quick point on 2D arrays. If I have a 2D array, let's call my 2D array, I don't know, let's call it stuff, and if it's something like There we go. I've got a two-dimensional array there up here. Each item in the array consists of two items, an array of two items, right? In order to access that, you specify, first of all, the first number that you specify is the first item in the list itself, right? Yeah, and then the second number that you specify is the item within that list. So for instance, if I wanted to pull out this item here, it's in this list and it's the first item in that list. So I would do something like stuff 1, 0 like that. Note that's not how you access it in Python. That's how you access it in the pseudocode, which OCR is likely to put on the on the paper. Okay, so the first number refers to whichever one of the individual sublists you want to access. Yeah, and then the second number refers to whatever item in that list you're pulling out. So when we say stuff 1 there, that effectively pulls out this list, which is 5, 2, yeah, and then when we specify item 0, well, the item at index 0 in that list is 5, so the output would be 5. Okay, hopefully that's cleared that up. Is there a simple way to transfer from hexadecimal? Yeah, hexadecimal's like simple, super simple. And I went through that in the previous stream, but let me do the sorting algorithms first, and then we'll rock on with the others. Okay, so get rid of that. So obviously, if you were in my lesson right now, I'd give you all a bunch of cards and get you to sort them. But let's just go through a bubble sort. Okay, so the way the bubble sort works. Is you start off by comparing the first two numbers, right? And if they need to be swapped over in order to get them into ascending order, you swap them over. But anytime you make a swap, you have to make a note that you've made a swap. Okay, so we're starting off at the moment. I'm going to put swapped here. At the moment, we haven't actually made any swaps. But first of all, we're going to swap 10 and 23. Okay, so 10 is definitely going in here. Now, 23 potentially is in here. But now we compare this number with this number. Do they need to swap? Well, 2 is less than 23, so yes, they do need to swap. So we swap them over, and 23 goes up here. Okay, we have made a swap. I should make a note of that, right? Now we've got 23 and 4. Okay, 23 is higher than 4, so they need to swap over. So 4 goes in here, 23 goes in here. Boom. Okay, we keep on doing this until we reach the end of the list. So we compare 23 to 8. They obviously need to swap. And we get 23 in here. We compare 23 to 60. They don't need to swap. So 60 just goes in there. Right? That's what the list looks like after the first pass. Okay. Now, just because we've reached the end, that doesn't mean that it is done. Okay. We need to go back. The computer will not know that the sort is complete until it's gone through without making any swaps. Is string manipulation 0 inclusive? Give me an example of what you mean by string manipulation. There's a lot of different string manipulation you can do. Okay, so we now start again. We compare 10 and 2. Do 10 and 2 need to swap? Yes, they do. But before we do that, we have to. Yeah, this is a bubble sort. Let's just say we're not gonna make any swap, right? Insertion sort's the easiest one, but we'll go over that next, right? So 10 and 2 need to swap. So 2 goes in there, 10 goes in here. Okay. 10 and 4, they need to swap as well. So 4 goes in here, 10 goes in here. 10 and 8 also need to swap. So 8 goes in here, 10 goes in here. I should note the fact that I've actually made a swap. 10 and 23 do not need to swap. At this point, right, we've moved 23 down, but we still have to compare 23 to 60. But you'll find that once the highest number in each pass is in its final position, right? 60 made it there that first pass. 23 has made it there this first pass. We know those two are sorted, so we don't have to go beyond that point, right? So now we're going to reset that. we go back to the beginning. Do 2 and 4 need to swap? No, they don't. So 2 goes in there. Do 4 and 8 need to swap? No, they don't. So 4 goes in there. Do 8 and 10 need to swap? No, they don't. So 8 goes in there. Do 10 and 23 need to swap? No, they don't. So 10 goes in there. Do 23 and 60 need to swap? No, they don't. 23 goes in there. 60 goes in there. You'll notice the last 2 passes are identical. That's because to get to this state we had to make a swap, and the computer doesn't know that it's sorted until you've made that full pass without making a swap. Okay, that's the bubble sort. Very inefficient, especially on large lists. But hopefully, that makes you confident that you've sort of got it. Now, some of you were saying the insertion sort is the one that you're not sure of. Right, I'm just going to answer Charlie's question here. Variable name 3, like that. So the way OCR does this stuff in their substring, right? If you had a string like hello dot substring 2, 5, right? The first number tells you the starting index. The second number tells you how many letters you are using. It's not the same as Python string slicing. Okay, so in your example, variable name, obviously that'll be variable name dot substring. 3 would be the starting index, and it would be 3 characters along from that. Okay. In Python, does something totally different. What am I using to stream? OBS. Right, next up. Boom, that's a bubble sort done. Brilliant, we've just done a lesson in 5 minutes. What have we got now? We've got insertion sort. This was the one that some of you were saying was too difficult. Here we go. So the insertion sort. The insertion sort. Here we go. What time? I'll be streaming until it's done. Obviously I'm not going to stay too late because you guys need an early night, and there's so much stuff. If you don't know it now, you're not going to know it. This is really to boost your existing knowledge, but hopefully I can fill in some of your gaps, right? So here we go. We've got an insertion sort here. Now with the insertion sort, you start out by declaring the first item in the list forms the entirety of the sorted list. Everything to the right of that is the unsorted list. Okay, so we start off and we say 23. That is a list and that is sorted. Okay, cool. So next what we do is we move across, if you like. We expand the sorted list to include the next item. And all we have to do is work out where in the sorted list that thing needs to slot in. That's why it's called the insertion sort. It's like you're picking it up and you're moving it along and you're putting it in at the bit where it needs to be. Okay, so in this instance 10 needs to go before 23, so we put 10 and we put 23 in there. Okay, and that's the first part of our insertion sort done. I'll tell you what, to make it a little bit easier to see what's going on, I'll change the text color. So sorted list is going to be in green, unsorted list is going to be in blue. Okay, so the next thing that we need to do, we've got our sorted list here. We extend the sorted list to include the next number along, but we need to slot that into the right place. So 2 needs to go before 23 and it needs to go before 10. So we put the 2 in there and we shuffle everything else along. 10 and 23 in there. Now everything else that's still part of the unsorted list, that moves down like that. Okay, is this starting to make sense, right? So next up, we do the same thing again. Here's our sorted list and we extend that sorted list to include the number 4, and we trace backwards through that sorted list until we find the place where it needs to be. Okay, so 4, yeah, it needs to go before 23, it needs to go before 10, but it doesn't go before 2, so we stick it in there and we shovel everything along. So we end up with 2, sorry, we end up with 2, 4, 10, 23 here. And we've still got these 2 bits down here. Does this make sense? And then we extend the sorted list to include the next item, okay, which in this case is 8, and again we are finding out where the 8 needs to go. So it needs to go before the 23, it needs to go before the 10, but it doesn't need to go before the 4. So we slot the 8 in there and shuffle everything else up. Okay, so the 8 goes in there, the 10 goes in there, the 23 goes in there, and the 60 comes down. And now we're done, because we've gone through every single item in the list. Okay? And that's all there is. That's all there is to the insertion sort. Okay? So remember, you start off by assuming the first item is sorted, and then you extend it one at a time. Right, guys, can you keep it civil in the chat, please? Otherwise I'm going to have to start muting people. You extend it one item at a time, and you slot that new item in exactly where it needs to go. Okay? That thing with my beard, I do it with a razor blade. Old-fashioned razor blade. Yeah. Right, any questions on the insertion sort before I move on to the merge sort? I'll take that as a no. Is that what? I mean, do you mean learn coding before the exam, or if you've got time? If you check my videos, there is a whole section. It's called Python from the ground up. It'll teach you from nothing all the way up, including getting the software installed on your machine and whatnot. Okay, so right. Fastest sort is probably the merge sort. Okay, so we'll move on to the merge sort next. Do we need to know the pseudocode for the sorts and searches? No, you don't. At least not really. I mean, there might be. I mean, you can sort of piece it together, but it's unlikely that you'll get something like that. They're more interested in knowing that you can do them rather than write the pseudocode. Okay. So next up. Oh, bear in mind as well, you won't be asked to write any Python on the exam. At least you won't be asked to write a full Python program. There might be a few questions where it's like implement this, this section in a high-level programming language or something like that. Okay. Next up is the merge sort. Okay. This one. It's actually pretty straightforward, but a lot of people sort of they worry about it for whatever reason. So the way that it works, okay, I'm going to color code this stuff again. You start off by splitting the numbers into individual lists. Okay, so as an example, if I have this list, which is 10, 8. 2, I'll tell you what, I'll use the correct syntax here. 10, 8, 2, 30, no, 60, 4, and 23, right? You start off by splitting them into individual lists, so you'll end up with something like 10, 8, 2, 60, 4, and 23. That's your starting point. Once they're split up into individual lists, that's what you do. Now you start merging them together. Okay, so the way that it works, you look at the first 2 lists. I'm going to color code these in red. Okay, so we've got these first 2 lists. You look at the first item in each of the lists. Now at the moment, the lists are only 1 item long, right? And so the first item is just the first item. Okay. First item is the only item. You split them into 4 and then 2, then individual. Well, yeah, I mean that's what you would do if you were coding it. But really, as long as you start off with a broken down list, then that's fine. I mean, you can do that. Yeah, I've just skipped along a bit to the point where it actually matters. This is the thing. Okay, so we're comparing the first item in each of these lists. Now the first item here is the lowest item here is an 8. So that moves down into this section here to form a new list. Now, you still have to compare the first item in each list. It's just that now this list has no items. Therefore, the only item that we're comparing is this one, which means that now moves down here and it forms its own. Now we've got this list of 2 items which are sorted. Okay. Now, it's very important to note, although when you start off it's a case of you move one down, then you move the other one down, when you get onto bigger lists you're not necessarily going to be doing it in that order, but we'll see what happens. How do you check greater than in binary? I'm not entirely sure what you mean by that. Okay, so we'll look at the next 2. I'm going to color code this in cyan. Okay, so once again we're looking at the first item in each list, and we are going to move that down to form the first item in our new list of 2. In fact, I'm going to color code the background of this as well, just to make sure that it's obvious that these are going to be separate lists, right? So now I'm moving, the 2 is the lowest one, so I'm going to move that down here. The 60 is next, so I'm going to move that down here, and there is my second list. Right, do you mean how do computers do that process? What they will do is subtract. They'll subtract the number from itself, and then like check to see. So subtract one number from the other number, and then check to see if the result is positive or negative. That's how they do it. So anyway, onto our final list then, or our final 2 lists, and we're going to merge them together. 4 is the lowest here, so we move that down there, and then 23 is the next one, so we move that down here. Okay, so now we've got 3 lists. Each of them are 2 items long. Okay, so we've got 8 and 10, that's our first list. We've got 2 and 60, that's our next list, and we've got 4 and 23. So now we compare 2 lists again. Remember, we are just looking at the first item in each of those 2 lists, right? And we move it down. So we're comparing 8 and 2 to start off with, right? We're comparing 8 and 2 because they are the first items in each of the lists. We move the lowest of those 2 down. Okay, so 2 is lower than 8, so that moves down. Now this next step, very important. It's not always just a case of bringing the opposite one down afterwards. No, you still have to compare the first item in each list. Now, 8 is the first item in this first list. 60 is now the first item in this second list. Okay, so instead of just automatically bringing that 8 down, we have to compare 8 and 60. Well, in this instance, 8 is lower than 60, so 8 is the next thing that comes down. Okay, so now we were comparing 8 and 60. It's not a case of just bringing the 60 down, because once again we're comparing the first item in each of these lists. So in this instance we've got 10, in this instance we've got 60. 10 is less than 60, so the 10 comes down now, and then the 60 follows behind. Okay, so I'm just going to highlight all of those as red, because they are all now part of the same list. Okay, and I will color code that with my grey color there. Okay, so now we've got this list. Now what happens to this list, because there's no other list to compare it to? Well, all that happens is it comes down next to the next list. We just move it down, we bring it down. Okay, I will cover your questions in a sec. Let me just carry on with this. All right, so now we've got one list of 4 items and we've got one list of 2 items. We go through exactly the same process. We look at the first item in each list. Okay, we've got 2 and we've got 4. Okay, so 2 is the lowest, so 2 comes down. Okay, now we have to compare the first item in each list again. We've got 8 here, we've got 4 here. 4 is the lowest, so 4 comes down here. There it is. Okay, again we're comparing the first item in each list. We've got 8 and we've got 23. 8 is the lowest, so 8 comes down. We're now comparing 10 and 23. 10 is the lowest, so 10 comes down. And now we're comparing 60 and 23. 23 is the lowest, so 23 comes down. And then 60 just comes down because there's nothing to compare it to. And that right there, ladies and gentlemen, is our final sorted list. Okay? And that's all there is to the merge sort. Okay? You've got to remember, always be comparing the first item in each list. Don't always assume that once you bring one down, you automatically bring the other down. You've got to always make sure that you are comparing that stuff. Okay? Right. The SQL statements like select variable where other... Yes, that is SQL. The only SQL statement that you need to know is select. Okay, so that's going to take the form of select something from something where something. Okay, so for example, if I wanted to pull out all of the items from the users table where username equals Bob or something like that, I would do something like select star from users where username equals Bob, like that. There's my SQL statement. You don't need to know anything other than the select statement. Okay? How do you write? How do you do the merge sort in the exam? Usually they will give you boxes. They'll give you a template to fill it in. Yeah, they'll give you a thing. If they don't, right? If they don't give you that template, here's what I suggest you do. Let me just revert all my changes. Control Z, man. Whoever invented that was a don. So if you had a list like this, for instance, I'll be moving on to audio after I've done these. I'm going to do the searches next, and then I'll move on to audio for you. All right. Right. The sorts. So as an example here, if you were doing the merge sort, right, we're given this list 10, 8, 2, 60, 4, 23, right? Start off, I mean, I would always use the your sort of pseudocode Python like list definition things using the square brackets. It's universally accepted that's it means this is a list. Start off by separating them into your individual lists. 10, 8, 2, 60, 4, 23, and then on the next line you just write in your merged lists. So you do 8, 10 like that, and then you'd have 2, 60 like that, and then 4, 23 like that. On your next line you're going to have 2, 8, 10, 60, and you're going to have 4 and 23, and then on your final line you're going to have the sorted list, which is going to be 2, 4, 8, 10, 23, 60. Just writing it out in individual stages like that shows your progression from one stage to the next. Okay. Same with bubble sort, same with insertion sort. If you write out each pass through the algorithm on a separate line, that's how you should do it. FYI, Marks and Spencer's Diet Sparkling Fiery Ginger Beer. It's pretty good. It's pretty good. It's all right. It's not the best ginger beer ever. I mean, it's not going to give Fentimans a run for its money, but it's pretty good. I go out there and get it. This is not a sponsored advert. Next up. Should we do some searches? Are you all cool with the whole what do you call it? What are they called? Sorting algorithms? Yeah. Okay. Should we do the search algorithms? Say yay or nay. Okay. All right. Now then. Right. So we're on to binary and linear searches. Boom. Here we go. There's a fun little exercise for you. There were some planets from Star Wars hidden in there. Probably won't get you to do that, but we will. I mean, can you try and find? I tell you what, we'll do a couple of them. Try and find the following planets. Try and find Alderaan. Try and find Dagobah. Try and find Kashyyyk, and try and find Coruscant. Okay. Okay. Those. See if you can. Yeah, I spelt it right this time, Gabe. Are you pleased? Are you happy? Yeah, that's what I thought. Okay, so when you're looking for this stuff, I want you to consider, are you just gazing aimlessly at a wall of text and hoping that the planets jump out at you, or are you using any particular... I'm not going to hate someone based on their movie preferences. I'm saying, are you using a specific method to find it? Because if you're starting at the start and you're sort of like saying, right, I'm looking for Alderaan. We're going along here. Where's the A? Oh, there's an A there. Nope, that's not it. I'm going to keep on going. No. Oh, we've got an Alderaan. Oh, found it. There it is. Alderaan. Okay. If you used that technique, then congratulations, you have just used the linear search. The linear search is ridiculously simple. Okay? This is the linear search. Okay? Start at the beginning of the list. Is this first item the thing that we are looking for? If it is, brilliant. You've found the thing you're looking for. If it's not, go on to the next thing. Is this next thing the thing we're looking for? If it is, brilliant, we found the thing we're looking for. If it's not, move on to the next thing. And so on until you find the thing that you are looking for, or you reach the end of the list. Okay? Now I've got an example here. Remember, we start counting indices at 0. Okay, so it might help if I write the index of each of these things above them. Okay, so as an example, right, if we are searching for the number 2 in this list, I will colour the indices in cyan so as not to confuse you. The list that we are searching for is this list here. This is the list that we are searching in. That is the haystack, if you like. Okay, and the things that we are searching for are these numbers. These are the needles, if you like. Okay, so to start off with, we look at index 0. What's the thing at index 0? It's a 1. Is 1 2? No. So we increase the index by 1. We are now looking at index 1. What's at index 1? Oh, it's a 4. Is 4 2? No, it's not. So we increase the index again. We're now looking at index 2. What's at index 2? It's 3. Is 3 2? No, it's not. So we increase the index again. We're now looking at index 3. What's at index 3? It's 2. Is 2 2? Yes, it is. Therefore, we have found the thing we're looking for. Therefore, 2 exists at index 3. Does that make sense? Does that make sense? Yep. Okay, so I mean, finding the other things is fairly trivial. Now, searching for something that is not in that list, what would happen is you'd go through the entire thing and you check the entire thing. So if I'm searching for, I don't know, 800, right, I say, right, what's at index 0? Is it 800? No. Right, what's the next one? Is it 800? No. Is that 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 800? No. Right, we've run out of things to check, so now I know that that item is not in the list. Okay? If you are searching for something that is not in the list, the algorithm has to go through the entire list before it can tell you that that item is not in the list, which is one of the things that makes the linear search inefficient with large lists. It's pretty damn efficient in small lists, okay? But larger lists, no. I was told you don't have to start at 0 in searches. Does it really matter, or could 2 take 4 searches? What do you mean, does 2 take 4 searches? And the linear search, you start at the very first item in your list. That's where you start. Okay. Now in the binary search, you start at a different point, but that's a different algorithm. Okay. Next up. I mean, I'm going to move on to the binary search. To find 2, it takes 3 searches. There's 1. There's 2. There's 3. Nope, takes 4. Takes 4 to find it. 1, 2, 3, 4. Okay? So we're cool with the linear search, yeah? It's alright, we all get a little bit ret star every so often. Usually when we're tired or stressed out or like, have an exam the next day or something like that, right? Cool. Right, let's go on to the binary search. Le search binaire, which I don't think is how you pronounce it in French, but who knows? Right, most important thing, most 100% importantest thing in the universe when dealing with binary search, the list has to be sorted first. If you are given a list and told to perform a binary search on it, you must sort the list first. If you are given a unsorted list and there's a question which is something like, explain why the binary search would be ineffective, because the list isn't sorted. Okay? Hello James, welcome to the party. There you go. Yep, welcome. Oh, by the way, Amy, if you're there, here is the duck that you got me. It is. I told you it was right next to my computer. It's right next to Adam Jensen from Deus Ex Human Revolution. So that's the one. Recherche binaire. Right. Okay. Rocking and rolling all night long. So we've got we've got to sort the list first, right? And then we are looking at the middle item in the list. Okay. So I've used the term search pointer here. When we implement binary searches, we use what's called a search pointer, which is the thing that we are looking for. Okay. So the way that the binary search works, it's more sophisticated than the linear search. If the middle item is the thing that we're looking for, then boom, we're done. But if the middle item is not the thing that we're looking for, then we need to work out if the middle item is higher or lower than the thing that we're looking for. And then we either switch to the top list or the bottom list, and we carry on the search from there. Okay? So I've got an example, I think. Here is my list. Okay, I've got 7, 12, 54, 278, 1,000, 65,535, and 9,999,999. Okay, so we are looking for the index of 12, we're looking for the index of 278, we're looking for the index of 15. And once again, I'm just going to write the indices above each item here for the sake of clarity. Okay, so here we are. I have all my indices above my my actual list. For God's sake, highlight it, Smith. There we go. Right. Okay. So to start off with, if there's no middle item, do you round up? Round up or round down? It doesn't matter. Either way is fine. It makes no difference. I mean, it all depends on your implementation. I tend to go lower. Other people tend to go higher. The reason being that it's more very slightly more processor intensive to round up than it is to just discard the remainder and go low. So that's that. So we've got 7 items in our list, okay, which means that the middle item, confusingly, because these numbers are so long, the middle item is 3, right? We've got 3 items on the left of 3, and we've got 3 items on the right of 3, which means that the middle index is 3, yeah? And the item at index 3 is 278. Okay, so we're looking for the number 12, right? You tell me now. This is a challenging question. Is 12 less than or greater than 278? I know it's a challenge, but let's see if you can do that. Is 12 less than or greater than 278? And answer with the appropriate pseudocode symbol, if you please. It's not equal to. So yeah, it is less than. Now, because 12 is less than 278, we know that 12 does not exist in this top half at all. So we don't concern ourselves with that now. Okay, we just worry about this list. Effectively, the new list that we're looking at is only 3 items long. Okay, so we find the middle item again. In this instance, it's index number 1. And we find out what's at index number 1. Here it is. And we compare that to 12. Now, you tell me once again, is 12 less than, equal to, or greater than 12? And use the appropriate operator again. Less than, equal to, or greater than. Yay! Equal to. Okay, which means we found that now. 12 is obviously, that's at index 1. Okay? Now, a stupid example here, 278, right? We search for the middle item here. That's the thing at index 3, right? And 278, well, we're looking for 278. 278 equals 278. Therefore, on our very first hit, we found the item. Okay? But let's just move down to this one, 15. We are going to search for 15. Okay? We've got to go through all of the stages. I pity the fool that doesn't prioritize computer science over chemistry. Obviously, I'm biased, but all I'm saying is if you go into even if you're more interested in chemistry than you are in computer science, if you go on to university to chemistry, you're going to have to know how to program. Just throwing that out there. So anyway, so we are searching for 15. Okay, we search the center index again. Okay, so 278. 278, well, 15 is obviously less than 278. 278 is greater than 15. So we know that we're not looking in this top list at all. We're only looking at the bottom list. So we search at index 1 because that's the middle item in this bottom list. Okay, so now we've got 12. And once again, tell me, is 15 less than, equal to, or greater than 12? Use the appropriate symbol. Yeah, binary search. I guess binary search is kind of like Thanos. Yeah, it's greater than. Okay, so 15 is greater than. So we've already got rid of this top lot, right? We're now moving on. So the only bit that we're looking in now, our list, our search item here, it's just one thing, right? And we're looking in here. So tell me now, is 54 less than, equal to, or greater than 15? Yeah, so 54 is greater than 15. Now the problem here is we know that that is not equal to 15. We know that we haven't found the thing, but we have already eradicated the rest of the list. Okay, which means we now know that the item is not in the list. We only had to search 3 times before we discovered that that item doesn't exist in the list. Whereas with a linear search, well, you tell me, how many searches would we have had to do using a linear search on this same list to discover that 15 is not in it? A 1 and a 2 and a 3 and a 4 and a 5 and a 6 and a 7 is correct. Okay, so you can see instantly how in certain situations the binary search is so much more efficient, right? So so yes, this leads me on to the next thing. Oh, look at the size of that finger. Yeah, I haven't had much sleep. The binary search is an example of a divide and conquer algorithm. Now here's a challenge for you. In the chat, can you explain to me what a divide and conquer algorithm is? And for bonus marks, can you give me an example of an algorithm other than the binary sort, which is a binary search even, which is a divide and conquer algorithm? Okay, so explain what a divide and conquer algorithm is, and if you could give me an example of a algorithm which is also are all computer science? Well, I mean, to be fair, I think decent computer science teachers are a rare breed. So if you've got a good one, then you know you're kind of lucky. So no, BOGO sort is not a divide and conquer algorithm. It breaks it down. There's a little bit more to it than just breaking it down, but you're thinking along the right lines. Okay. Yeah, you split it into parts. So every time the algorithm runs, the search space is halved. Okay, you are dividing the space that you are searching into, and you are conquering those little bits. Okay, if you do A level, you will also learn the quick sort, which is another example of a divide and conquer. Printing industry, yeah. You will also learn about the quick sort. That's also divide and conquer. Merge sort. The merge sort is effectively a divide and conquer algorithm because you are gradually reducing the number of lists as you go through it. Yeah. So yeah, as long as you understand, a divide and conquer algorithm is one that splits the search area up into smaller sections, gradually getting smaller and smaller until it finds the thing that it's looking for. And yes, as Michael quite rightly pointed out, you must make sure the list is sorted before you attempt the binary search. Is this also called bubble sort? No, it's totally wrong. I've already covered bubble sort earlier on, so either catch it on the rerun or go a little bit back. Decomposition, just before I'm going to move on to have a look at digital audio, right? But decomposition, that is where you start off with a big problem, right? You break that big problem down into smaller problems. Each of those smaller problems you look at and you break them down into even smaller problems until you're left with a bunch of teeny tiny small problems that are easily solvable. And then in the process of solving those problems, they join together to make the bigger problem seem a little bit less. For instance, if you are climbing Mount Kilimanjaro, if you stand at the bottom of Mount Kilimanjaro and you look at the top of Mount Kilimanjaro, you think to yourself, I am never ever getting to the top of that mountain. Trust me, I have been there. But what you do is you take it in stages. You say, right, I'm just going to get to the top of this next bit. Right, once I'm there, what's the next thing that I need to do? Okay, maybe I need to go down a little way and then I need to go back up again. Okay, you're breaking it down gradually into these stages. That is what decomposition is. But bear in mind, it is highly unlikely that you will be asked a question that says, what is decomposition? It's more likely that you will be asked a question which requires you to use your skills of decomposition to break a problem down into smaller ones. Abstraction, yes, that's where you get rid of irrelevant information. So you're taking a complex real-world situation, you're building a model of it by removing unnecessary information. The classic example is, in order to accurately predict the weather, we would need to know exactly what every single molecule of air was doing on the planet every single millisecond. Okay, now obviously that's ludicrous and we won't be able to monitor that. So what we do, we break it down into abstractions based on the readings from a number of different weather stations all around the world, and we can use the data that we have and previously gathered data as well to produce heuristics that will allow us to build up a model of what is likely to happen. Now the problem with using abstractions, anytime you're removing data, you're potentially reducing accuracy. Okay, so it's always a balancing act there. Yep, OCR High School, that's the place to be. I've just been to OCR Supermarket. That place is banging. Right, cool. And that's basically it for your algorithm stuff, right? I mean, it's really the thing to remember, right? Think about these things logically. Right, you go through it step by step, step by step. If there's a step that you can't remember, okay, just follow through with what you've got, because there's always the chance to get follow-through marks, even if you don't get it 100% correct. Okay. What about this then? Do you want to do this? Is that good? OCR is getting too powerful. Right, okay, digital audio. We will do this if you just give me a second. I've just got to do the thing that no one will talk about. I'll be back in like a minute. Okay? Discuss digital audio until I get back. We are back. Does what involve axolotls? I'm 100% behind anything that involves axolotls. Best of luck with your dinner, Michael. Have fun with that. What questions come up on digital audio? They usually ask stuff about sampling frequency and bit depth and how that affects audio quality. Alright, so should we do this? You want to find out about digital audio? Right, so is there anything particular that you want to know about like digital audio, or do you just want me to go through sort of like the whole shebang? Sampling, whole thing, please. Right, okay, we'll sort of like, we'll blast through this at a reasonably accelerated pace. Okay, so I'm not going to go over this whole thing. What is sound? You should all know that sound is like vibrations in the air, which can be represented as a wave. Yeah. Do you want to hear some? I mean, surely these should play. Do you want to hear some sounds? There you go. That's a 400 hertz sine wave, right? Here is a 400 hertz square wave. He says, trying desperately to play it. You can hear it's the same pitch. It's the same pitch, but it's a more like sort of biting sound, right? And then the sawtooth wave is the worst of both worlds. How annoying. If anyone wants schematics on how to build a device that will make those sounds, then I guess watch this space. Here is said device. It's kind of it's in pieces at the moment. I need to get a new battery for it. There you go. Anyway, so the whole point is, right, we have a wave, right? We need to store that on the computer somehow. But computers only understand binary. So what we need to do is somehow convert that wave into binary, right? And the way that we do that is by taking readings of the wave at set points at regular intervals, like throughout the course of the wave. Okay, so we take these regular measurements of the amplitude or the height of the wave, and we store that information. Right? The more frequently we take those measurements, the more accurate our sound is. Okay, the frequency that we take those measurements at is called the sampling frequency. So they might ask a question about sampling frequency. Describe how the quality of sound changes depending on the sampling frequency used. Okay. So the higher your sampling frequency, the higher the overall frequency of the waves you can capture. Okay, I've got a little diagram here. You can see here is a very, very simple waveform, right? You can see at regular intervals throughout this waveform, I have taken readings of the height of the wave. Okay, the frequency is measured in, well, one of you guys tell me what the frequency is measured in. Something tells me my thing isn't updating. Right, hertz. The frequency is measured in hertz. Right, now that might be hertz, that might be kilohertz, it might be megahertz, but depending on whether we actually need to hear it or not, hertz is what we want. What made you want to help a bunch of random year 11s and you don't get anything out of it? I mean, it's just the right thing to do, right? I mean, I'm here mostly for my students, but if other people get help out of it, you know, I started teaching because I wanted to help people. That's it basically. What do I get out of it? I get the knowledge that I've helped some young people get a decent start in their life. What else do I need? Anyway, the sampling frequency is measured in hertz. If you have a sampling frequency of, for instance, 10 hertz, that means 10 samples per second. Okay? 10 samples per second. So if I have, for instance, a sampling frequency of 20 kilohertz, how many samples per second is that? $20 kilohertz, not 2 kilohertz here. That's it. Yeah, 20,000. Okay, so if I've got a sampling frequency of 20 kilohertz, that is 20,000 samples per second. That's quite a lot, right? So the frequency range of human hearing, I'm not going to get you to go and find out, I'm just going to tell you. It's 20 hertz to 20 kilohertz. Generally speaking, humans cannot hear frequencies lower pitched than 20 hertz, and they cannot hear frequencies higher pitched than 20 kilohertz. Another thing is as you get older, the upper range seems to drop off a little bit. That's why sometimes outside of shops, people put those annoying sound things that they play sounds at a very high frequency just within the realm of human hearing, which is supposed to deter teenagers but be like imperceptible to anyone over the age of 20, and that's a total lie because I can hear them all the time. So 20 hertz to 20 kilohertz is the range of human hearing. Now, why is this important? Well, when you sample something, you need to make sure that you capture every part of the waveform, right? And in order to capture, what about I don't know about 5-year-olds. I mean, I just don't know. Don't ask questions like that. When you sample any sound, right, you need to sample at a frequency which is 2 times the highest frequency in your sound. Okay, so if the highest frequency in my wave is 15 kilohertz, in order to accurately capture that whole wave, I need to sample at 30 kilohertz. Okay, but anything, as themselves has just pointed out, anything over 20 kilohertz is unneeded data. Do they remove it for sampling? No, not in raw sampling, but it will be filtered out at the compression stage if it's being converted to something like an MP3 and stuff like that. Okay. The other thing as well is that there's something called psychoacoustics, which is way beyond the scope of this. But psychoacoustics it's the sounds that you can't hear, but because of the way they affect the wave, it's something that we as humans can perceive. So that's a whole other area. So we don't need to worry about that. Okay. But anyway, all of that stuff's not really important. But I wanted to give you this demonstration here of the difference in sound qualities, right? So when I've said 8 kilohertz telephone, I don't mean a mobile phone. He holds up nothing to his. I did have a mobile phone, don't know where it's gone. I don't mean a mobile phone. They usually have a higher quality. I mean like old-fashioned landline phones, right? 11 kilohertz, that's your low quality recordings. If you've got a dictaphone, if that, those like little personal sound recorders. Old arcade games used 11 kilohertz as well. 22 kilohertz, it's more like quality. That's your analog radio broadcasts. Now, all of that stuff, everything up to there, that's below the frequency range of human hearing, which means that the quality, it's perceptively lower. However, 44.1 kilohertz is the standard for audio recordings. That's why audio CDs generally sound pretty good. It's because they capture frequencies beyond the range of human hearing. Okay. 48 kilohertz is your professional digital audio recordings. 96 kilohertz is DVD audio, and again, the reasons for that is generally down to psychoacoustics, but also marketing plays a lot. There's a lot of people that claim that they can hear the differences between these, but they're lying. So there you go. Okay, so I've got some example sounds to play. I'm hoping I won't get hit with a copyright strike because this technically is fair use, and they're only short samples. So if you just bear with me here, I've got some low quality rap, I've got some high quality rap, I've got some low quality metal, and I've got some high quality metal here. Okay, to just show you the difference of like these different audios. Okay, so for instance here, this right here. This is French rap. Okay, there are swear words, but they're French swear words, so that makes it all right? But if we listen to this, and then I'm going to play you the high quality version, just see if you can notice the difference. Okay, so here's the low quality version.
Nord 2006. Je suis venu poser mes bombes, rien à foutre de vos histoires. Pareil pour Paris, ma ville, pour te donner le score. Je me souviens ça, traîner à la crèche, ça, cider à la fraîche, à une Heineken, pétard, la fraîche. On était morts nous, voyez les grands, ils avaient trop la cote. Soulever des mythes qui nous mettaient la colle. Puis on a grandi, et vite évolué. Et ma première charge, j'ai voulu lui fourrer ma langue dans la colle.
Okay, so there you go. I mean, like I said, there was a swear word in it, but it was a French swear word, so I think I'm all right with that. Okay, so next up, that was the low quality version. Here is the high quality version. See if you can notice any difference here.
Ma ville mec, Marignane, mon style, Nord 2006. Je suis venu poser mes bombes, rien à foutre de vos histoires. Pareil pour Paris, ma ville, pour te donner le score. Je me souviens ça, traîner à la crèche, ça, cider à la fraîche, à une Heineken, pétard, la fraîche. On était morts nous, voyez les grands, ils avaient trop la cote. Soulever des mythes qui nous mettaient la colle. Puis on a grandi, et vite évolué. Et ma première charge, j'ai voulu lui fourrer ma langue dans la colle.
Okay, so you can tell, obviously, there is a step up in quality. Like someone, now let's be careful here. It's not a better dynamic range, it's a better frequency response. Dynamic range is like bit depth, okay? So you can hear more of the sounds that are in there, okay? There's a greater range of frequencies that are available in there, okay? But with pop music and rap, because most of it is sort of mid-range stuff anyway, it doesn't often make that much difference. It's like, yeah, you could tell the difference in quality between those two, but there wasn't really that much in it. So classical music and metal, generally speaking, that has a much wider range of frequencies. You have like some very high frequencies, you have very low frequencies, and everything in between. And so a low quality metal recording will be more noticeably poor than a high quality one. This is Polish, so you got some French culture now, you get some Polish culture. So I'll play the low quality version first, and then the high quality version. What a tune. Okay, so that was the low quality version. Let's play the high quality version here. And if you complain about Slayer, Vader actually covered Seasons in the Abyss, and it was so much better. No, was it Seasons in? No, it was Rain in Blood, and it was so much better than the Slayer version. Just throwing that out there. Check it out. So here is the high quality version. Listen out for the sounds that you can now hear that you wouldn't be able to hear before. Oh, trust Tool are amazing. You know, I much prefer Tool to Vader. I'm just using this as an example. So anyway, let's get back to what we're saying. So obviously you can hear the higher frequencies. Okay, there's those symbols that are there in there. Okay, so the high frequencies are there. The higher your sampling frequency, the better the sound quality. Someone asked if it affects volume level. No, it does not affect volume level. It just affects the range of frequencies that are in there. But then there's this other thing called bit depth that you also need to know about, and that also affects the sound quality. Okay, now got another diagram here. Okay, so you can see here's my individual samples that I'm taking all the way along here, right? We cannot store a continuous waveform. At each point we have to convert the value to a binary value. Okay, we have to convert it to a binary value, right? And the way that we do that is by at each sampling point we look at the the point on this sort of like mapping, if you like, which is closest to where the waveform is. This is what's known as quantization. You don't need to know about quantization, but this is what it is. So you can see at my first sampling point here, I can see the waveform is pretty much on -4. The next one, it's on 0. The next one, it's on 4. Now the next one, it's midway between 6 and 7, and so I have to map it to one of them. It's closer to 7 than 6, so I map it to 7. Okay, so you can see here, this is equivalent of a there are 16 different values here. Okay, so if I've got 16 different values, how many bits would I need to represent that? If I've got 16 different values, how many bits would I need to represent that? See you later, Sam. Thanks for watching. How many bits? If I've got 16 different values, how many bits? Oh dear. No, not 15 bits to store 16 values. It's not 2 raised to the power of 16 because that's 65,536. You want to go the other way. You want fewer bits. Okay, how many bits do I need to store 2 values? Let's start out there. Right, silver wins. Well done. You need 4 bits to store 16. Remember, to store 2 values, it's 1 bit. To store, so 2 values is 1 bit. To store 4 values is 2 bits. Okay, to store 8 values, it's 3 bits. And to store 16 values, it is 4 bits. Okay? To store 32 values, it is 8 bits. No, it's 5 bits. What am I talking about? Okay, you double in each time. Yeah, it's log 2, 16. There you go. Okay? You should really know that. You know, I mean, but regardless, right? 4 bits is a very, very low bit rate. And just to go, someone was talking about using quantize to make your chords position correctly. Yeah, that's because what quantize means in that sense is it snaps the chords to the beat. And this is the same thing. Any form of quantization means snapping a discrete value onto snapping a continuous value onto a set of discrete values. Okay, so if I raised the number of bits, okay, if I had more of these lines going across here, I could get a more accurate picture of the waveform. Okay, the higher your bit depth, the higher the quality of the sound. Okay, sometimes it's known as quantization depth. Okay, but I believe the exam paper is just it just refers to it as bit depth. Okay, so it's the number of bits we use to store each sampled value. So just going back to my image here, we wouldn't store -8 as -8. We'd store it as 0000. We'd store -7 as 0001. We'd store -6 as 0010, and so on and so forth, all the way up to 1111 for 7. Okay? Yeah, no, I know log A is like higher level stuff, but you should know how many values can be represented with how many bits. That's what I'm saying. You don't need to, you know. I guess it's kind of like a volume slider, yeah. So the more bits, the higher the range in values, the greater the dynamic range of the recording. Okay, so the more bits you have, it's just like the number of, it's like, you know the difference between standard definition and high definition video? You know the difference between a 480p video and a 1080p video. There's more lines in the 1080p video, right? And it's the same thing. It's the same thing when you're displaying an image on a screen. There's quantization that goes into that, mapping the pixels to each part of the image. If you double the amount of lines, you double the amount of quality, right? Well, doubling the bit depth is essentially doubling the amount of lines that we've got going across here, and therefore you increase the quality that's on there. Okay. Here's some facts about bit depths. Okay, audio CDs are encoded using 16 bits. That gives you a signal-to-noise ratio of 96 decibels. The dynamic range of the human ear is around 120 decibels. That's why audio CDs are not quite perfect. The sampling frequency is fine, but the bit depth is not quite there. Okay, a bit depth of 20 bits, that gives you a signal-to-noise ratio of around 120 decibels, which is what the human ear can pick up. You don't need to know that. Okay, but I just thought it was interesting because there's nothing wrong with knowing more than you have to, just in case. Yeah? Okay, and that's pretty much all you need to know about digital audio and how digital audio is stored. Okay, so it's a case of you measure. Your sampling frequency tells you how frequently you are going to measure the wave, and the bit depth tells you how many different values there are for you to snap onto it. Okay, now you'll obviously, if I was to draw a line between all these individual dots, we'd get a fairly janky looking wave. It wouldn't quite be accurate, but it would be near as damn it. Okay, and that's where the sound quality changes. It's because like if it's not mapping onto those positions correctly, that's when you hear the different qualities. Okay, it's not frequency range; it's more points that can be picked up with the range of frequencies. Yes, it is. Yeah, that's exactly what it is. Okay, so. I wish I could show like with my hands. I don't have a board here, but I'll try and use the mouse. When you're reading along, okay, that's your how close or far apart the waveforms are. Okay, so you can see that one's fairly widely spaced and stuff like that. The higher your sampling frequency, the more of those rapid changes in the waveform that you'll pick up, and the higher your sampling rate, the higher your bit depth, the more of a smooth curve you'll get going over those bits when you actually measure it. Okay. Can I do some data? Well, I mean, this is data representation, yeah. The digital audio appears in the data representation section. Are you interested in binary conversions? Because I did that in the previous stream, which was on Tuesday, which is still up there, which you can go and check that out. But let's have a look and see what we've got on the thing. So we've been through algorithms. We have been through digital audio. We've been through some flowchart stuff. We've been through some thingy-jigamadoodas, flowcharts and pseudocode. Okay. Yeah, I mean, we can have a look at robust programs and things like that. ASCII I also covered in the previous stream, but just in a nutshell, every single character that can be displayed is mapped onto a specific value and stored in a table, and that value is converted into binary, and that's what stores the text. In order to pull out the value, you look up that value in binary, you read across, find out what the character is in the table, pull it out, and you display that. But you can go and have a look at that in the previous stream. See you later, Noisy. Have a best of luck with the exam tomorrow. I hope you do all right. Have you done? Yeah, we went through some pseudocode at the start of this stream, so you can check that out later, or you can go back and look at it now. But obviously you'll miss the bits that we're doing now. So let's have a look here. How important was the last stream? In the last stream we covered binary conversions every which way. So binary to denary, binary to hexadecimal, hexadecimal to denary, hexadecimal to binary, and all of that stuff. We also covered how images are stored, and we covered ASCII and Unicode, so that might be something worth looking at, but it's there, it's in the archive. I also streamed a few months back as well in preparation for the mock test, but I think that was mostly paper 1 stuff, so it's there. Okay, no problem. Go and enjoy your evening. How long was it in length? I don't know, a few hours maybe, but feel free to skip through it to find the bits you want. How long have we been on now? 2.5 hours almost. Okay, well, we might as well sort of carry on. I am going to have to wind it up at some point. I can't do it all night, and it's not good for you guys to be cramming in all night. So right, I have covered the binary to hex in the previous stream, but just quickly, I'll do this. If I have a binary number, an 8-bit binary number, for instance 01100001, okay, there's my 8-bit binary number, right? There's my 8-bit binary number. If I want to convert this to hexadecimal, first of all, I split it up into nibbles. Okay, so I'm splitting that up into 01100001. I've got 2 nibbles. Now, each of those nibbles corresponds to a single digit of hex. So we just convert those nibbles. Okay. Using the magic numbers 1, 2, 4, 8, I can see that this is 4 plus 2, which is 6. And same again, this is 1. Okay, once I've done that, I convert them together. That becomes 6, 1, and 01100001 in hexadecimal is 6, 1. Okay, to convert back the other way, so for instance, if I had, I don't know, CE or something, I wanted to convert that. Again, I split the individual digits up. Okay, I convert the letters to their corresponding numbers. So C is 12, okay, and E is 14. And then I convert them into individual binary nibbles. So 12 is 1100 and 14 is 1110. Okay, and then once I've done that, join them all together, 11001110. That's how you convert hexadecimal back to binary in a nutshell. Okay, now I did go into a lot of detail with all of this in the previous stream, so I'm not going to repeat myself now, because a lot of people that watch that, obviously they want to be doing the new stuff. But there's a free treat for you there. Yeah, I've got to bake them brownies. Don't worry, I'll sort it out. I've got all the stuff. I've got bananas in the fridge. I've got flour. What else do I need? Oh, I need to get some chocolate chips, and I need to get some cocoa powder, because I ran out when I was making those cakes for you last time. Do you always split? Yeah, when you're converting from binary to hexadecimal, that's the easiest way of doing it. Split it up and then join it back together. Did you have to fully complete the programming project? You had to have been allocated 20 hours to work on it, and that should have been submitted by your teacher. It doesn't form part of your grade, but they need to make sure that you have done it. But the other thing as well is the fact that most of the stuff that you would have done in that programming project, that feeds into the stuff that you're doing on this paper. Something like 40% of the questions are going to be relevant to stuff that you did during the programming project. So it might be worth, if you've still got access to it, having a look at what you did for that programming project. Things like error checking and testing, and like the planning that you did. All of that's going to be relevant to the exam. I'll briefly go through SQL in a sec. Let me just quickly have a look at what we've got down here. So programming techniques. Do you know what? I'm just going to scroll down to the thing. I googled that whole project. Probably not the best idea, really. Yeah, probably. I mean, you're sort of right. So erroneous data is data that you know should not work, right? Boundary data is data that is, it's right on the edge. You know that it should work, but it's at the limit. So if you had if you said enter a number between 1 and 10, 10 would be boundary data, because that's right on the edge. Yeah. La 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 la. Yeah, so the basics of SQL, you don't really need to know much. The only thing you need to know is the select statement. So, for instance, if I wanted to pull out all of the information from a table in a database, you say select. Okay, star means pull out all of the information. Select star from, and then the name of the table. So maybe select star from users. And then if you want to specify some conditions, you say where something like username equals Bob, for instance. Okay, so it always takes this format. Select something from something where something. Okay, so select star from users means select all of the data from the users table, but only for those records where the username is equal to Bob. Okay, I have covered that earlier, so I'm not going to dwell too much on it right now. Right, so variables, constants, operators, inputs, outputs, and assignments. We covered this last lesson. Someone tell me what the difference is between variable and a constant. No one knows. Yeah, variable changes, constant stays the same. I'm glad that was answered two different ways, because sometimes you get questions in the exam where it says, you know, state the difference between this thing and that thing. And if you just put, oh, variable changes, you will get 1 mark out of a possible 2. But if you put variable changes throughout the course of a program while a constant stays the same, you will get the 2 marks. So it might sound ludicrous if you've got, like, you know, this on one hand and that on the other hand. You just say, well, it's obvious what the other thing means. Just, you've got to explain it all. Make sure that you that you say it all. Okay. So here's a question for you, and this is a question that everyone always messes up. I want you to define a variable for me. Put it in the chat. What is a variable? Define variable. Something that changes is not an adequate answer. Way of storing data in memory is not an adequate answer. Just to answer Blessed question, how do I define a constant in pseudocode? Something like this. Something like that. An identifier where the data can be changed. That's more like it. A location in memory that is assigned a name that holds data. Oh my God! It's almost as if you memorized the definition that I told you. Yes. Okay. So a variable is a location in memory. There's 1 mark, which is assigned a name, 2 marks, whose contents change throughout the course of a program, 3 possible marks. Okay, if you say a place in memory that can change throughout a program when it runs, that's almost there, but it's not the place in memory that changes, it's the contents of that memory location. It's the thing that's stored in that memory place. Okay, so the definition is a location in memory that is assigned a name whose contents change throughout the course of a program. Okay. I mean, if you say a location in memory that is assigned a name that holds data, yeah, that'll do it as well. All right. So if you say something that changes, that's not enough. Okay, that would have got you through, one of the older exams possibly, but not anymore. You've got to be more specific there. Okay. A way of storing data in memory, that's closer, but that's still really a 1 mark answer. Okay. If you say a container, maybe if you said it's you'd be better off saying a memory location or a memory address. Okay, but the point is, if you say it's a name, that's not really enough. Okay, if you say it's a container that holds data which is assigned a name, that might be enough. But to play it safe, I would always mention the fact that it's a location in memory, because that's what it is. You know. La 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 la. Right, okay, cool. So operators, just spam in the chat. Give me some examples of the operators that you know. File handling may come up. It will possibly come up in a situation where they will give you some pseudocode, or they'll say design an algorithm that makes you do this, and so you just have to say, oh yeah, open file in read mode, blah 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 blah. You know, do all of that stuff. Yeah, cool. So we got some operators there. We've got multiplication, division, addition, subtraction. We got mod. We got div. We got raised to the power of. Be careful there, Noah. Although, yes, those are both operators. They are... Oh, I'm sorry. I didn't mean to laugh out loud when I saw XX Death 2002 XX. I used an example in one of my when I was doing about the legal issues, I used an example of someone that called the FBI on someone, or hacked into someone else while they were playing Call of Duty, and one of the characters I used was called XXX Death Star XXX. So that your name just made me laugh because it reminded me of that. Right, okay, so what was I saying? Yeah, operators. So Noah, you've put in // and you've put in %. Those are both Python operators, but bear in mind that in the OCR land, they, instead of instead of // they use div, and instead of the % they use mod. Okay, that's the thing. Yeah. Oh, was it Death Cloud? Okay. Dr. Destructo. Oh man. What an awesome lesson that was. We loved that lesson, right? Okay. Okay. My YouTube is a hacking games channel. Well, I did explain the processes of hacking computer save games using hex edit. That was part of my lesson. So there you go. What is exponentiation again? It's raising something to the power of something else. If I said 2 raised to the power of 7, that means 2 times 2 times 2 times 2 times 2 times 2 times 2. Does that make sense? Yeah, I'm going to take that as a yes. Okay, cool. So we know sequence, selection, and iteration, right? So just in case you're not sure, did I have to count that on my fingers? No, I didn't. Not that rubbish. Is this paper going to be harder than paper 1? It depends. It depends whether you are... some people find it harder, some people find it easier. Because of the way that I am, I always find the questions on paper 2 to be easier, but then a lot of the time I speak to my students and they say, oh, that was really hard. But it's an application of knowledge rather than a knowledge recall paper, you know, so it's... yeah, I mean, literally what Noah just said there. So yeah, so I always find paper 2 easier, but, you know, that's me. I think paper 2 is the more interesting of the two. I don't know if that means anything. So sequence. A sequence of instructions it's just a list of instructions which are carried out in order. So for instance, print hello, I don't know, I equals 6, I plus equals 12, print I. There is a sequence. Okay, it's a bunch of instructions. They're executed in order. There is no jumping around. There's no conditions or anything in there. That is a sequence. They may ask you about sequences. They might give you some pseudocode and say, oh yeah, what are the programming constructs? Okay, so these things are known as programming constructs. If you see the words programming constructs, it means they're looking for either of these words: sequence, selection, or iteration. Okay, so if you've got revision cards or whatever, you might do well to just write down programming constructs, sequence, selection, and iteration. Grade boundaries, I don't know, it depends. I mean, if everyone's getting all of my help, then presumably everyone's going to do super well, so maybe the grade boundaries will go up, right? But yeah, it always depends. So selection, yeah, that's an if statement. That's a condition. So if I say something like if name equals Smith, best teacher equals true, okay, else destroy planet, something like that. Okay, that is a example of selection. Okay, we've got an if statement. We're asking if the name is Smith. If the name is Smith, then we set the flag best teacher equals true. Otherwise, we destroy the planet. I know it's a bit harsh, but you know, what are you going to do? What's the difference between a single and a double equals? Very, very good question. And here is the answer. If you are assigning a value, so if you're doing something like name equals Bob, so we're setting up this variable called name and we're giving it a value, right? When you use a single equals, that's assignment. We take this value and we store it in this variable here. Okay, that's what the single equals means. If you are comparing something, that's when you use a double equals. So if I was then go on to do if name equals Bob, okay, you can see I use double equals there because it's a comparison. Okay. What does the open parentheses, close parentheses? That makes it a function call. If it's assumed that somewhere up here I would have a function, I don't know, def destroy planet, like that, okay, and then I'll put pass in there. If I call destroy planet, it won't actually destroy the planet, it'll just exit. Okay, so that's what those open parentheses, close parentheses mean. It's a function call. Okay, remember when you define a function, that code in that function is not run until you call the function later on. So if this was my whole program, the interpreter would look at this, it would say, okay, cool, there's a function called destroy planet. I'm not going to bother reading any of the code in that yet. I'm just going to move on to the next bit. It's going to print hello, it's going to assign the value 6 to I, it's going to add on 12, so I is now 18, it's going to print out 18, it's then going to check this. It will give me an error at that point because I haven't assigned a value to name, but whatever. I'll tell you what, if I put in name equals empty string, obviously if name equals Smith, well, it doesn't at the moment, so now we hit this bit, destroy planet, then the program goes all the way back up to the function and then it executes the code that's in it. Okay? So that's that. Yeah, iteration, I'm getting onto that now. So iteration is the third programming construct. There are two types of iteration. I can't see the camera, there we go, two types of iteration. And the first one is a count controlled loop, which is also known as a for loop. And the second one is a conditional loop, which is also known as a while loop. Now, if you're writing these things in pseudocode, you might do something like this. Let's say I want to output every number from 1 to 10, right? In pseudocode, I'd write something like this. For I equals 1 to 10, print I, next I. Okay, so when we hit this loop, what happens is it sets up this temporary variable I and it assigns it this first value. Now this is a range of values in Python. Remember, this is pseudocode here. If I was to do the same in Python, it would be something like this: for I in range 1, 11, like that. Print I, and I wouldn't have to put the next I in. So this here, that's pseudocode. And down here, this is Python. Okay, so you can see the difference there, right? So what happens is we get this temporary variable I. That is assigned to each value in this list as it goes through the loop. So to start off with, the value of I is 1. We are then going to print out that value of I. So we print out 1. Next I means go back to the start of the loop and assign the next value in the list. So the next value in the list is 2. So I is now 2. So when I go print I, I'm going to print out 2. And then next I sends me right back to the top again, and so on and so forth. Okay? So I equals 1 to 10. It will assign all of those different values as you go through. You just got to remember to put that next I on the end of it. It doesn't have to be I. You could call it Susan if you wanted to. For Susan equals 1 to 10, print Susan. Okay, and then obviously you'd have to do next Susan. Yeah, that's something that you could do. What about SQL? I've covered SQL twice already in this stream. Okay, so yeah, Blessed is on cue with that. Okay, so just yeah, rewatch bits of the stream to find out about SQL, right? I might do a little bit later on, but bear in mind I am human. I haven't had much sleep, and so I'm not going to be able to stream all night, and you guys need an early night as well. Okay, remember, I'm not doing this to teach you the whole course in 2 hours. I'm doing this to plaster over any cracks, you know. Right, so that covers count-controlled loops, count-controlled iteration. That is a for loop, right? A while loop is something that happens until a specific condition is no longer met. So, for instance, I could have something like num equals random 1 10. Okay, so in my made-up pseudocode here, what this means is select a random number between 1 and 10 and assign it to the value num. And then I could do something like this. While num does not equal 5, let's say, print not 5. Okay. Okay, so here's an example of a while loop, right? I am choosing a random number between 1 and 10, and I am assigning that to this variable num. I do that outside the loop, not inside the loop. Yeah. Next up, while num does not equal 5, we're going to do this. So maybe, let's say, for instance, my first random number is 4. Okay, so I then check this. So is num equal to 4? Actually, I've just realized this is going to be an infinite loop. So I'll just fix that. Num equals random 1, 10 again. So for instance here, while num does not equal 5, we're going to print not 5. So if I choose 4 to start off with, 4 is not 5, so I'm going to print not 5, and then I'm going to choose another random number. Okay, let's say I choose 8 this time. I hit the end while, so I go all the way back up. I check that condition again. Well, num is currently 8. That's not equal to 5, so I do it again. So I print not 5 again. Okay, and let's say this time I do choose 5. I still go back up to the top and I check that condition. While num does not equal 5, well, 5 does equal 5, so I then skip over that and I exit. Okay. It's unlikely that you will have to write any substantial amount of Python code. You will have to write a substantial amount of pseudocode, I would imagine. Okay, and sorry, I'm just reading the chat and trying to work out what is going on there. Something about a golf ball. It makes no sense. Where did I get up to? You'll have to write a bunch of pseudocode. You'll probably have to read and analyze some pseudocode. There might be a couple of questions where they ask you to write something in a high-level language. The thing to remember is, although a lot of schools teach Python, Python is not a specific language which is required by the paper. Any high-level language is accepted, and that includes things like C++ and C# and stuff like that. I think you'd have to be pretty insane to teach that at GCSE level, but some people do. So yeah, I mean, Python is a great language to start off with. So there you go. Okay, some of you might have done Visual Basic. Oh, sorry, I almost said it then. I almost said Visual Basic. Sorry, Visual Basic. Right, stop going on about golf balls, otherwise I will block you from the chat. You can do it in Java. If you're familiar with Java, that is fine. Doesn't matter. Right. Next up. Yeah. We all know about the programming language that shall not be named. Okay. Right. So I saw some of you were asking me to go through something. What is this death? I don't know what you're on about. File handling, right? You wanted to go through file handling. File handling is super duper simple, right? When you open a file, you either open a file in read mode, or you open a file in write mode, or you open a file in append mode. If you open a file in read mode, all you can do is read. Simple, right? If you open a file in write mode, you are going to overwrite everything that's in it. If you open a file in append mode, you are going to add what you want onto the end of it. So, for example, let's say I have a high scores table or something like that. Let's say I have a a function called get high scores, and it just returns a string which is going to be output to a text file, right? What I might want to do, I might do open high scores .txt in read mode. No, not in read mode, in write mode. Okay, that's the first bit. Okay, next up, in write mode or for writing or whatever, yeah, and then then you need to actually write something to it. Okay, so you could do something like write, let's say get high scores. Okay, write get high scores, and then last thing you need to do is close the file. Close high scores.txt. I mean, that's all there is to it in pseudocode. Obviously, it's different in Python, but the things to remember: if you're asked to write an algorithm which involves opening a file, you will get 1 mark for opening the file. You'll probably get another mark for opening it in the correct mode. You'll get a mark for writing the stuff that needs to be written, and you'll get a mark for closing it. Just remember, if you open your file, you've got to close it. Yeah? So just bear in mind, read mode, you can only read. Right? Write mode overwrites the entire file, and append mode will add your stuff to the end of the file. There you go. That's it. Okay. What's the bit at the end of the code that you add in pseudocode but not in Python? At the end of what code? I mean, what questions come up on file handling? You will usually have some sort of algorithm which involves you having to write some variables out to a file. That's usually what it is. Okay, sometimes it might be read variables in from a file, but that, I mean, that's pretty much like, what there is to it. Isn't Python a snake and pseudo a cream? I'm lost. I've never done coding. Death made me come here. Python is... Well, the Python programming language is not actually named after the snake. It's named after Monty Python's Flying Circus. So there you go. Just thought I'd throw that in. Oh yeah, endif. Right, so in Python, because Python is delimited by indentations, pseudocode... I have a Myonix X80, is it, or something? It's X65 or something. It's a decent keyboard. Okay, so what was I saying? Yeah, if you've got an if statement, so if I say if this equals that, for instance, do something. Okay, whereas in Python you'd leave it hanging like that. In pseudocode you should really put something like end-if at the end of it, right? If you've got a while loop, while Bob is old, laugh, for instance, and then at the end of that you would have an end while. Okay, it's just you saying, right, this is the end of that loop there. And the reason for it is because you don't necessarily... Yeah, it's a mechanical keyboard, that's why it sounds fairly large. Do you get marks for endif? If you have not used indentation but you put endif, you will not lose marks. If you have not used indentation but you haven't used endif, you might lose marks. So for instance, if you've done something like this, if you put if this equals that, do something, well, there's nothing to say this code block belongs to this condition. So if you're indenting it, then that should be fine, right? If you're not indenting it, you have to definitely have an endif in there. My advice is to use the closing statement and indentation just to be on the safe side. Okay. What would the questions actually be like then? Okay, I'll tell you what, right? We've gone through tons of theory and recapping stuff. We've been going for nearly 3 hours now, right? And so how about we go through some of those questions that are on the exam paper? These are questions that I pulled together from the OCR exam builder. So to give you an idea of the sorts of questions that might be on there. Why does your background look like it's sunny? Because it's sunny, man. It's sunny outside. What? You know, look. See? Sunny. Can't get... Oh, god damn it. Never take the webcam off the top of the... That's going to fall. Nope. Maybe? Yeah, that'll do. Okay, so... is it a Logitech C90? It's a maybe, maybe. Right, where are we go? What you got on under that beanie? It's not a beanie. It's a thing. It's my dreads. Okay. So right. Next up, where are we at? Big up the north. Right, we are not having a north-south battle here. Right. There will be no. You know, north versus south going on in this chat. Okay, if that's going to happen, I'm just going to end the stream now. Okay. Now, right. Okay. Next, right. So I'm going to pull up. Some example questions. Now, I think all of these are paper 2 questions. That is really not secure there. That's better. I think these are all paper 2 questions, but well, let's find out, shall we? All right. Where have they gone? Revision paper 2. Some of this is paper 1 stuff. I've just realised. A lot of that is paper 1 stuff. Okay, here we go. So here's an example question. Jim is writing a program to calculate the wages of workers in a teddy bear factory. Jim uses an integrated development environment, IDE, to create the program. Describe 2 tools in an IDE that can help Jim when creating the program. That question comes up an awful lot. Okay, so if you can name a couple of tools that help you out with programming that are in an IDE, bingo. And bear in mind, there are 4 marks available for this. So just writing color coding on debugger, that will only get you 2 marks. You've got to explain how they help as well. Okay? Because it doesn't say state, it says describe. If it says describe, that means tell me what it is and tell me what it does. Okay? Don't worry, I'll make the brownies. Okay, I'll have to go out to Tesco's to get the stuff, but you know what? I'll make the brownies. All right. Right. How do I sort this out? There you go. You can have a timeout. Okay. Yeah, I'm gonna bring down the ban hammer if the chat gets. If the chat gets like out of this. Can I have some brownies even though I'm nowhere? No, not unless you come to my revision session tomorrow morning. No, it's not hassle. I like baking. Okay, this is. I mean, you know me. I don't really have much in my life except for my students. So you know, and like baking brownies. That's kind of cool. All right. Yes. So let's have a look at this. So the debugger. As Oscar has pointed out here, the debugger allows you to step through your code line by line, which then allows you to pinpoint where errors occur. Okay? Next up, no, not weed brownies. I'm straight edge. I don't drink. I don't smoke. I don't do any drugs. Straight edge. You know. Next up. Other things, if you mention syntax highlighting allows the users to easily identify sections of code. They will be able to tell whether something is a variable, whether it is a number, whether it is a string. Okay? Error location, yes, it tells the user that there is an error, it tells the user what type of error it is, and it tells the user where to find that error. Okay? Alright, see you later, Mark. Have a good night's sleep tonight, alright? And I'll see you tomorrow morning. Okay, so yeah, so you're getting the hang of this now, yeah. You got to make sure that you are describing. I like my French doors are pretty rad, man. I mean, my house is pretty boss, if I do say so myself. I went through a lot of pain to get this house, so Yeah, it means a lot to me. Yeah. Right, let's scroll down here. That's a paper 1 looking thing. That's a paper 1 looking thing. Here's some paper 2 looking stuff. You guys know about logic gates, right? Yeah, you know about logic gates? Where's the missus? There is no missus. Okay, I'm single as AF. Single AF. Okay. Can component 1 stuff come up on paper 2? No. No. Although algorithm stuff can come up on paper 1, nothing from paper 1 will come up on paper 2 except for, like, you know, algorithm stuff. So let's look at this. 11A. State the output of each of the following logic circuits for the input given. Why aren't you married? Because I'm a terrible person, Charlie, that's why. So if I've got a NOT gate here, and 0 is going into it, what's coming out of it? And also if I've got an AND gate and I've got 0 and 1 coming into it, what's coming out of that? Just give me your answers down there. A marriage is not good. Marriage is archaic patriarchal oppression. There is no place for marriage in modern society. 1 and 0, yes, it is 1 and 0. Okay, so remember, a NOT gate inverts any input that's going into it, and an AND gate is only 1 if both of the inputs are 1. Okay? Do I have a dog? No, I don't have a dog. I don't want a mistress. Why are you trying to pair me off with people? Yeah, people might regret, but the thing is, like, this is all stuff that I say at school anyway, you know, so, you know. Right, guys, I'm going to have to put you on a timeout as well, aren't I? Boom, there you go. Yeah. Time out. Right, next up. So here we go. We've got this is a more complicated one now. You guys know about truth tables, I hope. Let's just zoom in on this a little bit so it's a little bit higher quality for you there to see. So we've got this. This is a compound logic circuit. Okay, we've got a NOT gate here, we've got an AND gate here, and the output is NOT P and Q. Now they've been pretty nice to you here because they've actually said NOT P and Q, whereas what really they should say, and what they probably would say these days, is they would have NOT P and Q, something like that. Okay, so you've got to know those symbols in terms of the what's it called? You've got to know those symbols in terms of the output. Average grade my students will get? I don't know. It's up to them. I'm hoping they'll all get at least a 5. There's 3 of them that I'm expecting to get 8s. Perhaps one of them, perhaps even a 9. If he doesn't, I'll be disappointed. You know who you are. So, or is the other way of AND? Let's check this out. What spec PC have I got? I've got a Intel 4930K overclocked to 4.5 gigahertz. I've got a Nvidia 2070 RTX, 32 gigabytes of RAM. And a Zonar DX sound card in it. Do you game on my PC? I'll be a bit stupid if I didn't, right? Yeah, of course I game on my PC. Right, let's have a look here. So should we fill out this truth table here? Can I actually write in this? Yes, I can. Right, let's fill out this truth table, shall we? Okay, so I'll tell you what. I will give you a couple of secs to have a go at filling out this truth table. Now remember, the way the truth tables work, you're reading across. So if P is O, if P is 0 and Q is 0, the output, not P and Q, is 0. If P is 1 and Q is 0, the output, not P and Q, is 0. The next thing would be if P is... Well, this is nonsense. They should have done it a different way. If P is 0 and Q is 1, what's the output? And then finally, if P is 1 and Q is 1. Okay? So yeah, you should have... Weasel was not my wrestling name. I told you, you'll find out my wrestling name if and when you get that 9. Right. So yeah, as a couple of you have already pointed out, 1 and 0, that's how you would fill out that truth table for that logic circuit. Okay. Now, similar questions that might come up along the same lines would be, they might give you the truth table and ask you to draw the relevant logic circuit. I mean, that's pretty tricky, but what they're more likely to do is to give you they're more likely to give you some sort of expression like this and ask you to draw the logic circuit and potentially complete the truth table for it as well. Will you have my children? Yeah, maybe not. I mean, I'm not really into that whole kids thing, so probably not. So... what symbol on the keyboard is OR? I mean, there is a specific symbol in the ASCII table. I just use a V. So there you go. All right. I'll just have a quick skim through here and see what else we got. We got another one, another logic gate one here. So you can see again, it shows not A and B. You are more likely to see something like this, not A and B, or something like that. It's more likely to appear like that. All right. So take care, guys. Get a good night's sleep. I'll see you all tomorrow morning. Okay. Those of you that are still here, let me just see how long we've been going for. We've been going for over 3 hours. I am going to have to cut it short fairly soon, but I'll just go through maybe a couple more of these questions, give you an idea of the sorts of things that might appear. Now, I don't know whether you'll get something as in-depth as this. A microwave oven is controlled by a small, specially built CPU. So, just out of interest, if a microwave oven is controlled by a small, specially built CPU, what type of device is in that microwave? An embedded system. Brilliant. Nice one, guys. Opcode and operand, that's more paper 1 stuff, and it's unlikely that it will show up, but I'll just point it out there. To identify the opcode, the opcode is usually at the start of the thing, and so you can see here the opcode for adding something is obviously 00001000, because that's the same there, and the opcode for subtracting is that. Unlikely that you'll get on that. That picture on my wall is it's Nighthawks by Edward Hopper. I might be able to, if you just bear with me a sec, might be able to find you a larger picture of it. Nope, I've spelled Edward wrong. There we go. So it's that. It's one of my favourite paintings. It's very nice. Will I do A-level computer science streams? Yeah, almost certainly. Almost certainly. Image and sound conversion. We have covered sound conversion in this stream, so you can backtrack through it and watch it. I covered image conversion in my previous stream, which was on Tuesday, so you can check that out. If you're interested in other cool stuff that I got on my wall, I don't know why I'm showing you this stuff, but maybe it's because I'm getting tired. I have this. This is a scissor blade from Kill la Kill, which is my favourite anime. This was given to me as a present from one of my former students. It's made of metal. He's had this like properly forged for me. How awesome is that? So anyway, let's just have a quick look and see if I don't think there's anything else really on this list of stuff. These are the sorts of questions that you're likely to get, right? You might get questions where they give you some pseudocode and they'll say the algorithm below is used to do XYZ, but it gives incorrect output. Explain why. And so what they want you to do is trace through it and work out where it's going wrong. Usually it will be some sort of logic error, right? What car do I drive? A Vauxhall Corsa. How awesome is that? But I'm probably going to buy a Nissan Leaf because I'm all about electric cars. Image and or sound question. Now you know what, that is a pretty good question. I tell you what, bear with, I might be able to provide said information. I might have to just search it up. Give me a second. I'm not going to get an i8. Next car is going to be fully electric. You know, I already get all my electricity from renewable sources. Oh no. Nope. There we go. Okay, right. So bear with me a sec. Let me see if I can dig up a likely question that's going to come up about sound and audio. Yeah, it's not about what your car looks like. It's about whether it serves the purpose that it intends to serve, and also how damaging it is to the environment. Right, here we go. Let's go to, what was it? Audio. Let's search for audio. Let's see what questions come up. So there's a question on sampling here. Is that going to display here? So Kofi uses his computer to record an audio file of himself playing his guitar. Outline what happens when the computer converts the music into a file. So it's only 2 marks, so you don't have to go into it in great depth. You just have to mention how the regular samples are taken, which measure the amplitude of the wave, and convert that to binary. Another question here. Let's see what this one says. Explain. Kofi increases the sample rate his computer is using to record his guitar. Explain 2 effects this will have on Kofi's recording. Well, as I demonstrated earlier with those sound files, the higher your sample rate, the better quality you're going to get. The higher the frequencies it can capture, the lower the sample rate, the worse the sound quality is going to be. Amplitude is how loud a sound is. Yeah, that's right. Okay. What is this website I'm using? It's the OCR exam builder, which you guys probably won't have access to. Okay, I don't even know if I'm allowed to show this stuff. But okay, there's a question about lossy compression as well. He emails his recording to a record label. He uses lossy compression to produce the music file. Explain 2 reasons why using lossy compression is beneficial. Okay, so those are the sorts of questions that you're going to get. I better get off that just in case. I'm not sure if I'm allowed to actually broadcast that. If I am, OCR, I'm sorry. Sorry, if I'm not, I'm sorry, OCR, I didn't mean to. Okay. So lossy compression, that's where your file size gets reduced, but at the expense of some data being lost. Classic example in images is JPEG, because you lose some of the data. The image becomes blurry when it gets compressed. But with a what's it called, audio file, MP3 is the classic lossy compression. Okay. The other one is lossless compression. That's where your file sizes get compressed, but you don't actually lose any data. PNG uses lossless compression, and FLAC is the audio format that uses lossless compression. Now the thing is, if you use lossy compression, you can reduce your file sizes you obviously lose that data, so you got a permanent loss of quality. With lossless, you don't lose any data, but you can't compress the files as much. I'm not showing you my garden. Right, I think I'm probably a little bit burnt out now because we've been going for over 3 hours. Although there's way more people here than I expected to be here, so. Hopefully, use lossless on Word docs. I mean, generally I wouldn't compress a Word doc, but yeah, I mean, anything that's text-based, if you're going to compress it, you're going to have to use lossless compression. So anyway, I am going to sign off. Some words of wisdom for you all. Read through the paper before you start answering questions. Make sure that you answer the easiest question first and leave the more tricky ones till later. If a question is worth 1 mark, spend a minute worrying about it. If you can't answer it, don't spend any longer. Pace yourself, 1 mark per minute. Okay, that's usually how it goes. 1 mark per minute, and then you'll have some time at the end. Okay. WAV is uncompressed. It doesn't use compression. The other thing as well, read through the question that you're answering at least twice before you start answering it, because it's very easy to give an amazing answer to a question that you haven't actually been asked. Okay. Other advice: get a good night's sleep, get a good breakfast tomorrow. Right. The other thing as well is do not stress too much. Okay. This is an important exam, but it's not the most important thing in the world. If you mess it up, you still have the rest of your life to fix things. You know, it's not the end of the world if you fail. Okay? Now, if you've got butterflies in your stomach, if you're a little bit nervous, that's natural. That's fine. Okay? But if you're so stressed that you can't sleep, that's too much, man, as that BoJack character would say. You know, you've got to just chill out a little bit and put things into perspective. Okay? So what you need to do is get a good night's sleep, try not to panic, and the other thing as well is if it's not in your head now, it's probably not going to get in your head by tomorrow afternoon. So don't worry about the bits that you don't know, worry about just making sure that the bits that you do know are there 100%. Okay, that's what you really need to do. Okay. There are plenty of other videos on this channel, like previous live streams that I've done. Yeah, they're your GCSEs, but they're your GCSEs. That's a good saying. Well done to your dad. Yeah. Yeah. Like I said, check out the other videos if you need to. But bear in mind, it's almost 9 o'clock, right? So have some time to yourselves, chill out, do whatever you do to relax, play some games, you know, just kick back, read a book, whatever. Okay, but give yourself some free time to sort of like de-stress, get a good night's sleep, get a decent breakfast, and you know what, you guys are going to smash it, every single one of you. Even if you're thinking, oh man, I don't know anything because my teacher's been rubbish, you know, do the best that you can. Okay, and never leave any question blank. If you leave a question blank, you are 100% getting 0 marks for that question. If you have a guess, no matter how wild it is, no matter how little you actually know about the subject, if you have a guess, you stand the chance of scraping some marks. Okay, it might be like a 2% chance of getting a mark, but you know what? 2% chance is an infinite number higher than 0%, yeah? So answer every single question. Alright? Right. If that's it, yeah, I mean, feel free to post a comment tomorrow. Let me know how you think you got on. I'll probably do a stream on results day as well, just to see how everyone's doing. You know, so you know, you got this, guys. And if you don't got it, then you've got some time to pick things up. It's not the end of the world if you mess up. And remember, you can still pass an A-level even with no computer science GCSE. I'm just throwing that out there, okay? So if you mess this up, don't worry, it's not the end of the world. Pick yourself up and do it. I have been through so much in my life where it seems like everything is over, but you know what? I picked myself up, I dusted myself off, and I got stuck back in, okay? And that's what you guys all need to do, okay? So don't panic, go in there with confidence, And what can I say? You guys are going to do fine. All right. Thank you very much, everybody. Here we go. Thanos moment.